have spelt the password incorrectly, as you will see here, which is really, really annoying. But again, actually, I could have edited this out and pretended it didn't happen, but it's probably going to happen to you. Certainly happened to me. So there should be an exclamation mark on the end of that. Oh my goodness, how frustrating. So we'll save that off. That should be right. Now we could test this locally actually by doing kind of a similar thing to what we did when we generated our migrations and make sure that we can connect in locally. Probably could be a good idea to do that now, but I'm going to be brave, not do that and be a bit foolhardy. So what we'll need to do, and what I'm going to do, is I'm going to kill that deployment because it's a bad deployment. It's not working. So let's do a bit of error management here. So I'm going to do we've already got our, that's our pods. So let's do kube ctl get deployments. And we can see we have this deployment and it's just, it's going to be in a bit of distress. So we'll do kube ctl delete deployment, and I'm just going to delete this. All right, so that's deleted now. So get our deployments, it's gone. If we get our pods, we have a terminating platforms deployment pod. So that's all good. So that's gone the way of the dodo. So make sure we're still in our platform service. We'll do a directory listing, make sure we have our Docker file. We're going to have to do that whole deployment step again. Now you can automate this, but again, I think when you're learning, I think it's good to go through this pain at least once or twice, and you will be very, very sure not to make these mistakes again. So we'll do a build. So Docker build tag, and then it's binary, in my case anyway, binary thistle / platform service. Okay, I'm just going to double check that, make sure I put the build context in. Get platform service, cool. Let's hit enter and build that. And that's built, and then we'll just push it up to Docker Hub once again. So let's take out this T and we'll change this to push. All right, we'll push up to Docker Hub again. Now, because we don't have a deployment now, I've destroyed it, we don't have a platforms deployment, we're going to have to go back into our K8s project and we're actually going to have to redeploy, reapply our deployment, okay? Because there's not one there. So you'll see it being created. So again, there's two distinctions there. If we have a deployment and it's running, you do the rollout restart. If we don't have any deployment, we have to do the application of the deployment. So we'll do that. Fingers crossed this time, we'll see what we get. All right, so that's been pushed up. Now again, I'm going to double check Docker Hub to make sure that it has been pushed up. So let's just refresh that. Fantastic, and we'll come in here and we will see it was updated a few seconds ago. And you can also see the count has been incremented. All right, so we do now need to actually go over to our K8s project. So let me just find that. That's this one here, and do a control backtick, and we'll do a directory listing. And we want to we actually basically want to deploy as if we were doing it for the first time, this deployment here. So again, just to labour the point, kube ctl get deployments. We don't have a platforms deployment, so kube ctl apply f, and we'll copy, should I say, this file here. Paste that in. And what you'll see is that our cluster IP service is unchanged, which is correct. That was already there, and our platform service deployment wasn't there, so it's being created. Great. So kubectl get deployments. Actually, let's do a get pods because that gives us a bit more detail. So we'll see container creating, and hopefully we don't see that dreaded error. There's nothing worse actually when you see that. It's kind of, your heart sinks a little bit and you think, oh my goodness, what have I done wrong? But it's all part of learning, so it's just part of how things end up being. So we'll check it again, and it's running this time. That is looking good. Let's do it one more time, because I find sometimes it can run. Maybe I spoke too soon, and then it's still running. That's good. So sometimes it can be a bit cheeky. You can do it, get pods, and it's running, and you're all happy. And you just do it again, and it's gone into an error state because it's actually failed. But that looks pretty good. Okay, fantastic. So what we'll do is we'll come over to Kubernetes now. That's not the wrong one. That's the Docker Hub. It looks a bit similar. They're using the same color scheme, so that's why I'm getting a bit confused with it. So let me bring that onto the screen here. And we'll do a quick look at the terminal window to see what we get. So here's our platform service deployment. And we can take a quick look at some of the output that we're getting here. We can see, if I scroll up, yep, we're using SQL Server database. We're attempting to apply migrations, all looking good. And then we're seeding data into our database. So looking pretty good, I think. So the proof of the pudding really is to come back over to SQL Server and refresh it. Refresh this. There we go. We've got a platforms DB. And we should have platforms table. If we do a new query, we should have our seeded data in there as well. So just make sure if you're using this tool that you change it to platforms DB up here. And we'll do a select everything from platforms. Great. Indeed we do. That is looking pretty good. And then if we come over to Insomnia, and I'll bring this up. Make sure you're using the K8 version. We can do get all platforms, and that's all looking good as well. Now what we might want to do if we want to be really, really brave is we want to do a create platform, but this time we'll just duplicate this. And we'll move this into here. And we will just copy this URI into here. And we will create Docker in our database, and that will be the full proof that everything is working. So that's looking good. We get a 201 created. We'll do a get all platforms from here. It's looking pretty good. And then we'll just come back to our SQL Server Management Studio and we'll just execute that. And it's there. Whew. Quite a long section, but a very worthwhile section. So we've got SQL Server up and running in our cluster now. We have using a persistent volume claim, awesome, and then we have changed our platform service to make use of SQL Server when it's running in Kubernetes, but to still use an in-memory database when it's running in development. So a little bit of a nuanced setup. Fantastic. So what we are going to come on to doing next is we're going to revisit our commands service because it's very, very bare bones at the moment. It just basically has that one test endpoint in it. So we're actually going to build that out to be a more fully featured service. You'll probably be quite pleased to hear we're not going to go down the route of provisioning its own SQL Server. We're just going to continue to use an in-memory database for that because we've covered that already. And as maybe as a challenge for yourself or a bit of homework, you can do that. You have all the information now to be able to stand up a SQL Server just for command service. And I'll leave that for you. But yes, in the next section, what we're going to do is revisit our command service and then kind of get it up to speed as a proper service. And then beyond that, we're going to start looking at more interesting messaging between the two services in a proper microservices style. So we'll do that next. Okay, so before we begin coding, let's take a quick look at the endpoints we're going to have to build, stand up in our commands service. Now this conversation is really more a REST conversation as opposed to a microservices conversation. There are some kind of crossover touch points, but for the most part, this really isn't anything really to do with microservices. This is really to do with the fact that our commands service is going to be dealing with two models. A commands model, as you would expect. In fact, let's take a look. A commands model, as you would expect, which will store the command line snippets, but it's also going to have to deal with a platform model. Now, where microservices conversation comes into this, obviously, we are going to spend a lot of time figuring out how to get platforms from our platform service down into our command service and use this concept of eventual consistency where we have something created in one service, our platform service, and it's somehow replicated or transmitted or event-driven, whatever, down to other services, in this case, our command service. So that's the microservice problem. Taking that aside for the moment and just looking at this purely from the lens of the command service is going to eventually have platform data, okay? We will solve that problem. So let's say the command service is going to have platforms and it's also going to have commands, okay? And so what we're really talking about here is how do we enable our command service to work with multi-models. Now, when we talk about just about platforms, a platform you could almost think as the parent resource in this case. And again, our command service is not responsible for creating platforms or anything like that, but what we will allow it to do is allow someone to return the platforms that it is aware of, okay? So that is what we're going to do next pretty much, and we will put that into our existing platform controller. And you'll remember we did create a platform controller with a test endpoint just to test connectivity. So that's fairly straightforward. But the whole point of this section is really saying that a platform is effectively the parent of a command. And maybe putting it another way, a command cannot exist outside a platform without a platform. So as you can see here with these next three endpoints, they're all going to be part of or reside within the commands controller, which we will set up. And probably the most important thing that you'll note here is that the route for all our actions is going to has to contain the resource ID for a valid platform. So for example, taking a look at how we're going to create a command, we cannot create a command without a platform. Hence, we have to provide a resource ID as part of the route when we are creating a command. And the same rules apply for when we are retrieving commands or even retrieving a specific command. We have to do it in reference to a platform. So again, that's it really for this section. It's really just to get you up to speed on the fact that this is how we're going to have to create our commands controller, and it's going to make reference to valid platforms as part of the route. Yeah, so gets you across that, and hopefully it made sense. If not, then we are going to come on to coding next, for hopefully it will become much clearer. So why don't we get started? All right, so we're coming back into some familiar territory now and back into a more coding type structure, which I personally prefer. And we're going to make sure we're in our commands service project. Now you'll remember, it's been a while, fairly basic. In fact, we didn't really do too much with it at all. All we had was this platforms controller where we had a test post event just to make sure that we could communicate between our services. And that was all we did with it. We don't really have anything else in here. We did, of course, have a Docker file, which we need, and that's not going to change. But other than that, very, very, very basic, even over in our startup class. I don't believe there was too much here. In fact, I didn't even take out the default comments, so I'm just going to do that, which I usually like to do. All right, fantastic. So the first thing we're going to do is create our models. So over in the root of our project, right click, new folder, models. And the first model we're going to create is our platform model. So new file, platform.cs. So we'll create a namespace of command service, and this is models. Fantastic. And we're going to declare a public class called platform. And then we're going to define some properties. So prop, integer, tab across, we'll call this ID. Fantastic. And then prop, we'll call this, we'll give it a type string, and then we'll call it name. And we'll leave it there for the moment. Now what we might actually want to do, and in fact what I might do, is I might put another property in here, an integer, and we'll call it, I don't know, external ID, and that's going to be the primary key of the platform from our platform service, because we might want to keep track of what that is, possibly. So we'll stick a pin in that for the moment, but we'll use that. So this is really a reference to any unique ID that we get given by the platform service. We may want to track that, and of course we have our own unique database ID, which we'll use kind of internally. That's it for now. The other model we want to create is our command model. So right click in models, new file, and we'll call this command.cs. So namespace, command service, models, and again it's a public class called command. And we'll define a couple of properties on it. First one is an integer, we'll call ID, all good. And then the next one, we'll make a prop. This time it's a string. We'll call this one how to. So how to do a particular activity, such as build a .NET project. Next property, we will have that also as a string. Not a string, and we'll call that command line. And then we'll have a few more properties. Still an ID, and this one is our platform ID. So this is the kind of foreign key reference back to our platform parent, if you like. And then finally, we'll create a public platform of type platform. I didn't quite do a property there, did I? But never mind, I'll fill it out manually. Now this is basically what's called a navigation property, so it allows us to kind of navigate between commands and platforms by providing a reference to our platform there. Now, well, remember, let's jump back over to our platform class, and we want to also, in here, make a reference to the fact that we have a collection, or can have a collection, so we'll use iCollection, of command objects. So again, this is navigating the other way, and we'll call that commands get and set. And we'll make that equal to a new list of command objects. All right, so we need to bring in a couple of namespaces and correct our spelling. Collection, using system collections generic. I think that should be enough, yeah. So there we go. And the other thing that we do need to do, which I hadn't done, is we'll need to annotate these attributes as well. So I want to make sure that the string, or the name, sorry, is required. We'll make sure the external ID is also required. And we'll make sure that this is required. And we'll also specify that it's a key. And we'll bring in the namespace for data annotations. And that all looks good. So we'll save that off. And then back over in our commands, likewise, we will make this required. We'll also make it the key. Our how to will be required. As with our command line, it wouldn't be a terribly interesting command if we didn't have a, if we didn't have a command line snippet in there. And then likewise, our platform ID needs to be required. Okay. And we'll bring in the namespace for that. And that should resolve. Fantastic. So I'll save that off. And we'll do a control backtick, and we'll just do a .NET build just to make sure we didn't introduce any strange errors into here. That all looks pretty good. So in the next section, again, with this service, we're just going to use an in-memory database, but we still need to add a database context. And actually within our DB context, we want to set up some, we'll specify explicitly some relationships between, or a relationship between our platform model and our commands model as well. Entity Framework does a lot of that for us, but if we want to be really explicit about it to make sure we get the exact behavior you want, then you should set up those behaviors, and we do that within our DB context class. So we'll do that next. All right, so we want to create our DB context now. So let's just get rid of this, and back over in our command service, like we did with the platform service, we're just going to right click, new folder, and we're going to call it data. And in here, we're going to create a new file called appdbcontext.cs. And this is, well, the first bit is exactly the same as we have already done for our platform service. So namespace, command service, data, and we're going to declare a public class called appdbcontext. And it's going to inherit from dbcontext. And we'll bring in that namespace with control period. and then curly brackets. We then want to declare a constructor, so CTOR, tab into this, and we want to declare some db context options, and of what type, app db context. And we're going to specify some options, again exactly as we've already done for our platform service. All good. And then likewise, we're going to do a couple of properties, db set, so type db set, and it's going to be db set of type platform. Let's bring that space in using command service models, and we'll call that platforms. And then we get a second prop, again it's a db set of type command, and we're going to call that commands. Fantastic. Now, as I said just a little while ago, that should be sufficient, and Entity Framework Core does a pretty good job of wiring up the relationships using its defaults, but just to be on the safe side, I'm going to explicitly declare the relationships between these two entities, because the naming conventions can be a little bit weird when you leave it to Entity Framework Core. So I'm just going to explicitly declare that here. And the way you do that is, yes, within your DB context, but we just need to override a method. So protected override, what are we overriding? Well, void first of all, and then we're overriding on model creating. And we pass into that a model builder. We'll just call that model builder. And using this model builder, we then specify the relationships we want to declare on our two entities, two models. So entity, first one we're using is platform. And then we just declare the relationships. So we'll say has many. And then we will use a lambda expression. So P goes to P commands. So platform has many commands with one. Again, using a lambda, P goes to P platform. Put the exclamation mark in. And then finally, has foreign key. Lambda expression again. Platform ID. And we'll finish that off with a semicolon. That all looks pretty good. And then we kind of do the reverse, going the other way from, for our command. So model builder again, specify the entity we're working with, so type command. Fantastic. And then we just specify it has one. And we use a lambda expression again. P goes to P platform with many. So it's kind of the reverse relationship definition effectively. Commands. And then finally has foreign key. P goes to P platform ID. Fantastic. So we can save that off, and I think that all looks pretty good. So again, we'll just do clear the screen here, and we'll do a .NET build just to make sure that's all humming along nicely. And it is fantastic. So we're going to again use the repository pattern here. So in the next bit, the next section, we're going to add a repository. So we'll do that next. All right, so let's close this down. Let's get rid of our DB context, and still within our data folder, we're going to create our repository interface. So right click data, new file. We're going to call this I command repo.cs. Namespace as usual, command service, oh, not models, data. And then we just declare the interface as public. Interface, we'll call it I command repo. So again, because we'll be using a database, we want to specify save changes, which, we always technically have to do, so save changes. And then I'm going to create a number of method signatures here, and there's some that most of them will make sense, and most of them will service those endpoints that I showed you in the slideware, and there's going to be one that wasn't there because it's not actually an endpoint that we're going to expose via our HTTP controllers, but it's something we're going to have to be able to do when we come on to doing the microservice asynchronous messaging, and that is adding platforms into our database, platforms that we're going to get somehow from our platform service. That's when it really starts to get exciting. So anyway, let's begin. So the first method signature I'm going to declare is a IEnumerable of type platform. A few namespaces to bring here. I'm just going to call it get all platforms. Okay, so that will allow us to get all the platforms from our command service, the ones that it knows about anyway. So let's bring in these namespaces, systems generic, systems collection generic, and our models namespace. Fantastic. Next one is going to be a void, and it's going to be called create platform. So again, we are going to eventually need to create platforms in our database, and we'll do that generally by getting that data from elsewhere, from our platform service. So yep, it will take a platform object ultimately. And then we need to create this method as well, platform exists, and you'll see how that comes into play a little bit later. And into that, we are expecting to pass a platform ID. So basically, this is just checking to see whether this given platform ID does exist within our collection of platforms. And we will use this quite a lot, actually, throughout the rest of the course. And we'll see how that comes into play a bit later. So this stuff is really all about the commands. So I might just actually, you can read the code, I suppose, but I might just put platform. Sorry, this is all about platforms, not commands. This is platform-related stuff, even though it's in our command service. And this next range of methods are really about our commands. And these ones really relate to the endpoints, mostly, that I showed you on the last slide where. So the first one is going to be an IEnumerable. It's going to be a type command. So it's going to return a list of commands. And we're going to call it get commands for platform. And it's going to expect a platform ID. So we give it a platform ID, and we're going to give it back all the commands that relate to that platform ID. The next one is going to be returning back a single command. We're going to call it get command. And into that, we are going to expect a platform ID, but also a command ID. So that's giving us an individual command, if you remember from the routes that we had on the slide. And then last one, possibly the most important, well, as equally important, is void create command. And into that, we're going to expect the platform ID of the platform that we want to create the command on, and then a command object called command. And that's our full range of method signatures that this interface needs to provide for us. And if we just come back just over to this slide here, you'll see here that we have most stuff relating to, so we got something that will give us all our platforms, and then these are our three command-based operations here, getting all commands for a platform, getting a single command for a platform, and then creating a command. And the only one that we didn't have on there is this one here, creating a platform, which we do by other more mysterious, more interesting methods. Fantastic. So that's our interface done. We'll move on now to creating an implementation class for our iCommand repo interface. All right, so we're going to create our concrete implementation class for our command repo interface. So right-click data, make sure I've selected that, right-click data, new file, and we'll call this command repo.cs. So namespace, command service.data, and it's just a public class called command repo. And we're going to implement our iCommand repo interface. Fantastic. And so just click in here, control period, implement our interface. Just before we do actually fully implement it, we've only got placeholder stuff here. I'm going to first create a constructor, so CTOR, and I'm going to pass in an app DB context. T in there, and we'll call that context. And we will assign that to a private read-only field called _context. Fantastic, and as usual we need to create that, of course, so control period and generate read-only field. Perfect. So let's move down to the bottom and we'll start working our way up the top. Start with the simplest ones first, so save changes. Again, we need to call save changes anytime we add or delete anything from the DB context, and so it actually gets pushed down to the persistence layer. So context, save changes, and we'll return true if the value of save changes is greater than 0, how many things we have affected or impacted. We'll return true. Next one is whether we have a platform existing in our collection. So we'll pass in a platform ID and return either true or false based on whether something exists. So return context again. And this time we're going to look in our platforms collection and we're going to see if we have anything at all in there matching the following criteria. So control period to bring in the link. And so quick lambda expression, so P goes to P and we will look for the ID and see whether it's equivalent to the platform ID that's passed in. And if so, we'll return true. If it doesn't find anything, then we will return false. Next, we want to get all the commands for a particular platform. So we're going to pass in a platform ID and we will return any commands that we have, if any. We could get a null back. That is a valid response. So return _context, this time in our commands, and we will do where, and we'll do another lambda expression. So C goes to C. This time we're looking at the platform ID to see whether it's equivalent to the platform ID pulled in. And if so, you don't need to do this, but I'm going to do it. We're going to order the results by the platform name, just so we have them kind of grouped together. So C goes to C once again, platform name. Not mandatory, but just makes our result set a little bit nicer. Fantastic. Next one, we're going to get an individual command. So we're going to pass in both the platform ID and the command ID. And so we're going to return context, commands, where. And our where clause is a little bit more complex this time. So C goes to C, and the first thing we'll check is the platform ID to see if it's equivalent to the platform ID passed in. But also, so and, we want to check to see if the command ID is the equivalent to the command ID passed in. Now let's do a control B to get rid of our file explorer. And what we want here is the first or default. Okay, we don't want a full result set, we just want a singular command returned back. Next one, get all platforms. This is pretty easy, so we're just going to return back using the context again. Platforms to list. Simple as that. And then slightly more interesting ones, we've got a couple of create methods here. So the first one is creating a platform. So in order to do that, we first want to check to see if the platform object that was passed in, we're going to make sure it's not null. We don't want to try and add a null value to our collection. So if it is null, then we will throw a new argument null exception. And I'll just bring in the system namespace, assuming I spelt that correctly, and amazingly I did. And we'll say name of plat. Okay, so what model are we throwing an exception on? Assuming it's not null, then we will use our context again, and we'll simply go to our platforms collection and add the platform that we've been given. And then finally, probably the most complex method of all, although it's not really that complicated, we are going to add a command. So we're going to get passed in the platform ID, and we are going to expect a command object passed in as well. Now, we're already getting the platform ID from the URI. So if we come back to our list of methods, let me just find the right slide. I just want to show you what I'm talking about. Here we go. So for create a command, this is going to be our route. So we're going to go platforms, platform ID, commands, and we're going to create a command at that route. So we're already getting the platform ID here. So when we actually pass in the command, although the command does need a platform ID, we don't need to specify that in the body of our create or of our post request. That'll become a bit more clear when we create the DTOs for this. But I'm going to do a little bit of code in here that you might go, why are you doing that? But that's basically why. So basically, similarly to the creating platform, if the command passed in is equivalent to null, then we don't want to do that. So I'm just going to copy this rather than typing it. And instead of plat, it's going to be a command. So assuming it's not null, what we then want to do on the command object that's been passed in, you want to set the platform ID equal to the platform ID that we get in the URI. Now I'll take that out from here. That should be, excuse me, that should be down here. That's why I was getting that warning. So I'm going to go as unreachable code. So yes, just to replay that again, we get a command passed in, but we're not going to have a platform ID at that point. We're already getting it in the URI. So I'm going to assign the platform ID to whatever is in our route. And then finally, context. On our commands collection, I'm going to just simply add that command. Fantastic, and I think that's us done. I think that's the concrete class done. That's all our methods implemented. Looks that way anyway. So I'm just going to do a control backtick, and I'm just going to do a .NET build. Make sure we've not broken anything. That all looks good, fantastic. So that's basically our repository done. What we're going to move on to doing next is creating our DTOs, because then next we're going to move on to fully implementing our controllers. But first we need to get our DTOs in place, and then actually we need to do our mappings as well. So we'll do that next. All right, so we are coming on now to creating our DTOs. So Control B to bring back our Command Explorer, and I'm just going to get rid of these for the moment. Well, not get rid of them, but just clear them down. So in our root of our commands service project, right click and new folder, and we're going to create a folder called DTOs. Now we're not going to create all the DTOs that we need right now. We're going to create the ones that map just to the controller actions that we're going to implement. Okay, there are some other DTOs that we're going to create as we move forward, more related to eventing and all that kind of stuff. But these DTOs, we're just creating the ones we need just to service our controllers. So the first DTO we're going to create, I'm not going to go through what DTOs are again because we've already gone through that. The first one I'm going to create is a platform read DTO. So new file, platform read DTO, not .DTO, but platform read DTO.cs. All right, and so namespace, command service, DTOs. And it's super simple. It's a public class called platform read DTO. And we're going to have two properties. Prop, first one is the ID. We want to return back the ID of any platforms that we have, and it's an integer, so that's all nice and easy. And then likewise for our name, assuming I can spell prop correctly, but this time it's a string, not a sting, a string, and it's a type name. Just going back to our models, just to kind of review, here's a platform model. It's pretty much exactly the same as that. Not quite, but it's got our ID and our name. We're not going to pass back our external ID. We're just passing back our ID and the name. Can of course change that if we so choose to a bit later on, but for the moment, that's all we want. Just quickly looking at our command model, just before we move on any further, we have an ID, a how-to, and a command line. And a platform ID, we actually want to return all of these back via our command read DTO. So back over in DTOs, right click, new file, and we'll call this command read dto.cs. The namespace, command service, DTOs, and it's just a public class called command read DTO. And let me come back to our platform, and I'm just going to copy this in, copy these in here, over here. And I'm going to take out the annotations because again it's a read DTO, so I don't really feel we need those. Take these out, and that's fine. So when we are returning a command object back as part of our response, this is what we're going to be passing back. And we're going to save that off. And the only other one that we're going to implement for what we're doing next in our controller is when we want to create a command. So right click DTOs, new file, and it's command create dto.cs. Namespace, command service, DTOs. Now I appreciate a lot of this stuff is quite boring, we've done it before, but again it's good practice. We've still not really come on to the really interesting stuff yet, which is when we start using eventing and all that kind of stuff. This is just still pretty much web API, to be really honest with you. But we're almost getting there. So again, command service, it's just going to be a public class called command create DTO. Now, again, thinking when we want to create a command, what are the things that we're going to pass over? What do we want to actually create with? And we've come back to our command class. We have an ID, which again, as you know, we do not want to pass over. Like with our platform service, we're not going to supply the ID, so we don't need to include that. I mentioned already, and again, this is maybe still a little bit confusing, we do need the platform ID, but we're not going to expect that as part of our body payload because we already get given it in our URI. So this is surplus to requirements. Although it's still needed, we don't need to get it as part of our body payload. Otherwise, we'd be duplicating the platform ID, and conceivably the route ID and the ID we pass here could be different, it could be confusing. So we're just not going to allow it to get passed over at all. So all really our command create DTO is going to expect is how to and command line platform IDs passed in the URI. So I'm just going to copy this. Hopefully that made sense, but it will when we come on to actually doing it. And again, because it's a read DTO, I'm going to leave these as required, and we'll bring in the data annotations namespace, and I think we're good. Did we, from memory, let's have a look. No, that's good. We didn't put any other considerations on that. So that's all good, so we'll save that off. So I think that's good. So let's just do a quick build again, just to make sure nothing's broken. I don't think that would break anything. Cool, so again, at this point, all we're trying to do is get our commands service up and running almost just from a web API perspective. We'll do a quick test if we can, and then we're going to move on to the more interesting stuff, which is actually getting these services to properly talk to each other using an event bus. And that is going to be coming up in the section that follows. We're almost there, but next we have to do our controller. So let's move on to that. Now actually, just before we move on, I'm actually forgetting a very important thing, and that is AutoMapper. We have not included AutoMapper yet. Again, remember AutoMapper is the glue that allows us to map between our models and our DTOs, and we've not put that in yet. So first thing I want to check is just to check that we included it in our CSproj file, and we did. So over here, AutoMapper extensions, Microsoft dependency injection, we need that in here. And you will also remember it has to go into our startup class, but I don't believe we have done that yet. No, we haven't. So first things first, we want to add AutoMapper into our configure services method. So under controllers, we're going to access our services collection and we're going to add AutoMapper. And it is there. And again, you'll remember from before, we need to pass in this app domain, current domain, get assemblies, and we'll finish that off. So that allows us to inject AutoMapper in our service. Fantastic. Now this is getting a bit busy now, so I'm going to close all this down. So all that really remains for us to do is actually create the mappings. So again, you'll remember we created a folder for those mappings, or for those profiles, more correctly. So new folder, and we'll call it profiles. Okay, so in the profiles folder, new file, we're going to call our profile commands profile.cs. And its namespace, command service, profiles. Again, be careful with the pluralization of the namespace, profiles, and the automapper class profile that we implement. So public class commands profile, and we're going to implement an automapper class called profile. I'll bring in the automapper namespace. So hopefully you should remember this from last time. And then we just create a constructor called commands profile. We don't accept any parameters, and it's in here that we do our mappings. So just a bit of a refresh, we will specify our source and then our target. Now again, the mappings that we're going to do at the moment are very simple. They just map kind of straight on top of each other, as you will remember from last time. This does get a little bit more complex though. So we will come back in here and update our mappings at some point, but for now, simply create map. And the first one that we want to create is from our platform object to our platform read DTO. So that's when we're giving back platforms from our controller. The source ultimately is a platform model, and the target is a platform read DTO. So I'll just bring in command service models, and I'll bring in the DTO namespace as well. Fantastic. That's our first mapping done. Should make sense. And then the next one, create map, and this is going to be a command, create DTO, and that is ultimately going to be going to a command. Fantastic, and I think that's all we need to do. Oh, and then possibly the third one, create command, or create map, should I say. And the source is going to be a command, and we're going to turn back a command read DTO. So again, likewise, when we're retrieving our command objects, the source is going to be a command, and we're going to be passing back a command read DTO. And that's our three mappings for the moment. And I think this is, yeah, I don't know why that's wrong. There we go, that should be much better. Don't know how that got to be a small p. Anyway, there we go, that's our constructor done. Matching our platform, all good, yep. Maybe it got it from here, that's interesting. I didn't realize that. You can see here that the name of the file is a small p. And that's maybe where it's getting the name of the constructor. I didn't realize that. I thought it would have got it from the class. Interesting. There we go, something I learned. So good pickup there anyway. So we'll save that off. That's our commands profile done. So yeah, now we are truly ready to move on to our controllers. All right, so moving on to controllers now. And if we come back over here, you can see that we had a platforms controller already here that we created just to test this inbound connection. Now you can see it's pretty basic. There's enough here to get us going, but we need to obviously expand upon that. Now we did create a constructor, it's not doing very much at the moment, so as usual what we want to do is inject in a repository so we can use it and a mapper object. So the first thing we're going to inject in is an I command repo repository, and we'll call that repository. No comma, don't know why I put that in. And we also want to inject an I mapper for automapper, and we'll call that mapper, and we'll bring those namespaces in. So using command service data and using automapper. And as usual, we will assign both of those to private read-only fields. So underscore repository equals repository, and underscore mapper equals mapper. And we'll bring in the namespaces for these. Now, before we move any, so read-only field, and same for this, read-only field. Now, before we move any further with this, this will actually fail if we try and run up this class and or run up the application and attempt to hit one of our action endpoints. We're going to get some horrible errors here, and if anybody can tell why, then you're obviously following along very well indeed. The main reason is that we've not registered our iCommander repo in our startup class, in our configure services method, and actually nor have we configured our database context. We've not registered that either. We weren't using any data services from in here, when we were testing it before, so we set none of that stuff up in our startup class. So if we come over here, you can see our configure services method is looking pretty bare. We just have our controllers, which was there anyway, and then we did add automapper, but we haven't yet registered our DB context, which we need to do, and we haven't yet registered our repository. So before we go any further, we need to do that. So up here, we'll make use of our services collection again, and we're going to add DB context, and it's going to be an app DB context. There we go. I'm going to provide some options, OPT. Now I'm just going to get rid of a sidebar for a minute, the directory listing. So lambda expression, if I can type it correctly, OPT goes to use in memory database. And I suspect we need to bring in a namespace for that, so let's do that. Control period to bring in, yep, entity framework core, and then as before we just need to give the in-memory database a name, so I'll just call it anything, it doesn't really matter. And again, we're not going to use a SQL server here, and we're not going to distinguish between environments, we're just using the in-memory database just in the interest of time. But again, I've said it before, key point to note is that this service, the command service, does have its own database. All right, cool, and then finally, that's our DB context registered. We now need to register our repository. So let me just put it in here actually. So services, add scoped. So we're going to, when anybody requests an I command repo, we're going to give them, should I spell it correctly? We're going to give them a concrete class, which is command repo. And that's it. So yeah, I think that's all in the namespace is there. I think that's right. So let me just do a build, save it first. .NET build. Yeah, that's all good. All right, perfect. So that's all our dependency injection stuff wired up for our data stuff anyway, so we can close that down and we can come back to our controller. So this stuff will now work. So when we ask for one of these, it will get injected in, so that's all good. So we're in our platforms controller at the moment, and let's come back to our slide deck and we'll just have a look at the action that we're going to implement for that. So I can find the right slide. Bear with me a second. Here we go. So again, we're going to have two controllers within the command service. We're going to have our platforms controller, and that's just going to allow us to get all our platforms. So let's set on doing that first. So it's going to be a HTTP GET request. No routes or anything, it's just going to use the existing route, which as you can see here is API/C and then the name of the controller, which in this case will be platforms. Fantastic. And then it's just a public action result, passing back an IEnumerable of what platform read DTOs. And we'll call that get platforms. It will require a couple of namespaces, so systems collections generic and platform read DTO. So command service DTOs. Fantastic. So I'm just going to do a console write line just to give us a wee bit debugging, because I find that quite useful, especially when things go wrong, as you've seen recently. So I'll just say getting platforms from, oh goodness, command service, or command service more correctly. All right, fantastic. So that should just give us a bit of warning that this controller action has actually been hit when we call it. So we then want to get a collection of, if there are any, a collection of platforms back using a repository. So I'll create a variable called platform items equals, make use of our repository, and let's just get all platforms. I don't need to pass anything into that. So it's inconceivable this could be null, that's okay. And in fact it is going to be null for very obvious reasons, which we'll cover in a second. And then we're just going to return back an OK and we're going to make use of AutoMapper. So we're going to map from our collection of models to a collection of read DTOs. So mapper, map, what do we want to map to? We want to map to an I enumerable of platform read DTOs. And what's our source? Our source is our platform items. And again, that's just making use of one of our mappings in our profile. So that all looks good. Fantastic. So let's give this a go. Let's run this up, .NET Run. And let's come over to Insomnia and test this endpoint. Now it's not going to return anything, it's just going to return an empty set, but I just want to make sure that we've wired everything up correctly and we're not getting any weird issues. So we are running in our local environment. So we're just done a .NET Run. So command service, here's the previous test we did on the inbound connection. In fact, we could probably still test that. And that's working okay. If we come back over here, you can see, yep, we've got an inbound post. So again, we'd expect that to continue to work, but at least we've not introduced any new errors. And so the new thing we want to introduce here is basically a get all commands. So new request, not all commands, sorry, get all platforms. Put space in here, there we go, get request, we'll create that. And I'm just going to copy the URI from here, because it's going to be exactly the same. The only difference is it's a get request, not a post request. Send that over. Great. So we got 200 OK and just an empty array of nothing, because there's nothing there. We've not seeded any data. We didn't create a prep. Well, we've got a prep D class from memory, haven't we? So we just come over here, Control C that, get rid of this. Bring up our data folder. No, we don't. I forgot. We didn't actually even create a prep DB class like we did with our platform service where we seeded data and all that kind of stuff. We don't even have one yet. We will in a bit, but for now we don't. So there's nothing there. We just have an empty database with nothing in it. So that's cool for the moment. We'll circle back to this problem with the fact that we have no data for platforms. But for the next part, what we're going to do is we're going to finish off the other action results that we need to put into our commands controller. So we'll do that in the next section. All right, so what we want to do now is create our second controller, our commands controller, that will allow us to service requests for commands. So before we do anything, let's just take a quick review of the endpoints we're going to stand up. So we've done this first one, again, and that was in our platforms controller. I should actually pluralize these, but in our platforms controller, we allowed the ability to pull back all platforms. For the remaining three, that's where our new controller comes in, our commands controller. And you'll see in all three instances, the route is exactly the same, with the exception of the second one, which is an additional parameter, the command ID. But taking that aside, all three of these routes are exactly the same. So this is our kind of controller level routes. Let's just take a quick look. API/C platforms, we're then passing in a platform ID in all cases, it's a mandatory requirement, and then our commands resource. And in this case, we're passing through a command ID. So just try and remember that this is the kind of class level route that we need to put in. So back over in our project, right click on controllers, new file, and we're going to call this controller or commands controller.cs. So namespace, as usual, command service, controllers, it's just a public class called commands controller. And we're going to inherit from controller base. I'll need to bring that namespace in. Fantastic. Okay, cool. Now, before we come on to doing constructors or anything like that, we want to actually decorate our class with the fact that it is an API controller. Fantastic. And we also want to specify the route. So if we come back to our platforms controller, you can see the route that the class level, or the controller level route was API/C, and then the name of our controller, which in this case was platforms. Over here, we want to do something similar, but coming again, just to refresh your memory, although it wasn't that long ago, we want to have our route as API/C platforms. Now, bear in mind our controller is our commands controller, so we have to actually write platforms as a string. We need to figure out a way to provide in an attribute, a parameter, platform ID, which we have done before, so it shouldn't be too, in fact, if actually showing you the syntax here, shouldn't be too controversial. And then finally, inheriting the name of our controller. So, back over here, we want to specify the route. And then we just specify the route. So it's API /C/platforms / an instance where we inject in our platform ID parameter, which will be the resource ID of our given platform, and then finally the name of our controller, which we will use the kind of wildcard syntax, so controller. Okay, so that just picks up this commands portion and puts it in here. So that gives us our class level or our controller level route, which is pretty much the same for all our actions apart from one, where we have to add on an additional parameter. Cool, so before we come on to the action results, let's do our constructor. So CTOR, and as usual, let me just get rid of the stuff at the side here, Control B. As usual, we're going to pass in an I command repo called repository. And we're going to pass in an I mapper object as well, called mapper. And then private read-only fields. So you should definitely, I did tell you we'd be doing a lot of this stuff, and I know it's probably getting a bit laborious, but again, all good practice. Equals mapper. And we'll bring in the namespaces for each of these. Control period. Not namespaces, my apologies. We're going to generate a read-only field. I'm just so used to saying that, bringing in the namespace. So generate a read-only field for both. And we do actually, we do need to bring in the namespace for these. So let's do that. Command service data and using automapper. Fantastic. So namespaces for these, both these things, and private read-only variables for that. Fantastic. So let's come on to our first action result, which is to get back all the commands for a given platform. So it's going to be a HTTP GET. I'm not going to bring up the slide again. I think you've seen that enough. Let me just move this up a little bit. It's going to be a public action result. And what we're going to pass back, we're going to pass back an IEnumerable of what? Of command read DTOs. And we'll call this method get commands for platform. Spell platform correctly. And then we want to pass in the platform ID. Fantastic. So we will get our platform ID from our route up here. So whatever resource or platform ID we pass in, we will get that down here. So bring in the namespaces for IEnumerable, system collections generic, and also for our DTOs. There we go. Now the first thing we want to do, well I want to do anyway, is do a console, bring in the namespace, using system, right line, just to say that we've hit this controller. Again, this is not something you typically do in production, but while we are doing some test code, I think it's useful. So we'll use string interpolation. It will just say hit get commands for platform, and we'll just put the ID in to make sure that's all flowing through correctly. Platform ID. Fantastic. All right, now we don't want to attempt to get commands for a platform if that platform doesn't exist within our database. So the first thing we're going to do, and I'll do a Control B and we come back to our repository, is we did put this method in here, platform exists, with passing that platform ID, and that's really exists to just check to see, do we have a relevant platform in our collection? If not, then there's no point in trying to do anything else, and we return back a false or not found or whatever. So we'll make use of that now. So we'll say if, and we make use of our repository. If repository platform exists, we'll pass in the platform ID. And actually I want to make this a not. So if it doesn't exist, so exclamation mark. So if we get a false back from this, i.e. it doesn't exist, then we will return a not found HTTP 401. And that's it. We won't do anything else there. Assuming that our platform is valid and it does exist, we want to pull back a variable of our commands. So var commands, and this is coming from our repository, and we want to get commands for platform, and that expects a platform ID, so we just pass that through. And we can be fairly sure that we have at least got a valid platform, having done this check up here. And then we just return an OK, 200 response, and we have to map back, so mapper, map, what we're mapping to, an I enumerable of what, command read DTOs, and what's our source, our commands. Fantastic. Okay, so that looks good. Now, of course, we can try and test this, but we're just going to get a not found. So let's try it. And again, we're going to get a not found because we have no platforms. But again, that's the problem that you're hopefully starting to see. We have no platforms in our entire service. How are we going to get around that? Well, that's really where we come on to using some nice asynchronous messaging to get some platforms into our controller, into our command service. But nonetheless, we can still test this endpoint to some extent to make sure we get a 404, or 401 is it? I can't remember. 404 not found. 401 is not authorized, that's right. So bring up our command line, we'll make sure everything's saved. We'll do a .NET run. And again, it's always useful to run this stuff intermittently just to make sure that we're not introducing anything weird. So I'm going to just duplicate this one. And I'm going to say get all commands for platform. Okay. And in here, we're going to maintain this is the same, API /C/ platforms. We'll put in some arbitrary resource ID for our non-existent platform, and then we'll have to amend this on commands. Okay. So yes, we get a 404 not found, which is what we expect as we don't have any platform IDs, but that looks okay. It looks like that's kind of being hit. And if we actually come back over here, you can see here, we had our, again, exactly the reason why I provide this kind of stuff or put stuff in. We did hit our controller correctly with a platform ID of 1, and we just didn't find anything. So that's all looking pretty good. So I'll take a quick pause here for the moment, and then we'll come on and we'll finish off our other 2 action results for this commands controller. And then we'll start to look at what we're going to do about this problem about not having any commands in this service. How are we going to get them in there? So we'll do that next. All right, so let's just kill that. And yeah, we're going to come on and finish off the final 2 action results or endpoints for our commands controller. So the next one we want to write up is basically to pull back an individual command for a given platform. So HTTP GET. I'm not going to bring up the routes again because I'm sure you've seen them enough already, but you'll remember from this one, we need to additionally pass in a command ID as well. So the controller level route takes us so far, but we need to pass in another parameter, which is our command ID. So HTTP GET, open parenthesis, double quotes, and then we just need to specify in our curly brackets command ID as an additional route parameter. That's all right. And then we also, or I'm going to, specify the name of this action result because we'll make reference to this a bit later when we come on to create a command. And this should start to be familiar from when we created platforms in the last service that we built. So I'm going to call it get command for platform. And that's all good. And then it's just a public action result of type command read DTO. We'll just bring back a single command if we find one. And the name, I'm just going to copy this to make sure it's exactly correct and exactly the same. Don't want to introduce any weird errors into this at this stage. And then we're going to expect 2 parameters. So the first one is the platform ID. And the second one is an integer as well, and it's the command ID. Select that there. Okay, so platform ID is coming from our controller level route here, and the command ID is coming from our action result level route here. Fantastic. So the first thing we want to do actually is do a very similar, not very similar, an exactly identical check here to make sure that the platform ID exists. And I'm going to also copy this right line as well. So again, platform doesn't exist, there's no point in doing anything else. So I'll just change the name of this. So get command for platform. I'll paste that in here. And we'll pass through the platform ID, and we'll also pass through the command ID, just to help us with a bit of debugging if it comes to that, command ID. Fantastic. So again, you're starting to see the problem that we're going to hit here. We have no way of, at this point in getting platforms into this particular service. So all these action results, all three of them in fact, are going to just return a 404 not found because we have no platforms. So the problem, and start to think about it, is how are we getting platforms? How should we get platforms into this service? Should we just create another controller action and just allow us to add platforms? We could do that, but we're not going to, because the whole point is we want to actually get our platforms from our platform service in some nice, elegant way, some event-driven, asynchronous way. Anyway, so yeah, let's just finish off this action result before we delve into that too much further. So yeah, we are doing a platform check to see if it exists. If it does exist, that's all well and good. And what we want to then do is return the individual command. So var command equals repository, and we're going to call our get command method this time. And into that, we're going to pass our platform ID and also our command ID. Now, again, at this point, we may or may not have a command. It's entirely valid use case that there is no command there. That's okay. So we need to check that first of all. So we'll say if command is null, then we go no further and we will just return a not found as before. And make sure we put in the double equal signs for equivalency. We're not assigning it. That's cool. And then, assuming that's okay, then we just return okay. We do, of course, have to use mapper. So what are we mapping? Mapper map. What are we mapping to? We're mapping to whatever we are returning, which is a command read DTO. And what's our source? Just the command object that we have up here, which is non-null. Fantastic. So again, that's all looking good. We'll save that off. We'll quickly run it up. Now again, we're just going to hit this first not found condition here, but we can at least see that we get that number one and it's working correctly, and that we're getting both our IDs coming through correctly. So .NET run. And then back over in Insomnia, we will come into our command service under our local dev, and I'm going to duplicate this. I'm going to call it get command for platform. Okay, and it's going to look exactly the same, except we're going to hit on or put on an additional parameter for our command. Still get a 404, which is fine, but what I do want to check to see in our output is that we are hit the controller and we pass through number one for the platform ID and number three for the command ID. So that's about as far as we can take this at this point in time. Cool. So that just leaves the final action result, which is our create command action result. So we'll do that next. All right, so just stop any running services if you have any, and we're back in our command controller, and we're going to write up our third action result. So back down here, pick a new line, and I'm just going to pull this up. So this is a HTTP post this time, and we don't need to specify any additional routes because our controller level route is exactly the one that we want. And again, to labour the point, we have a HTTP get here. It's a different verb, obviously, from HTTP post. So they're hitting the same route, different verbs. It's still unique within the controller, so that's all good. So let's come on to the method signature. So public action result. What are we going to return back? We're going to return back a command read DTO. We're attempting to create a command here. If we do successfully, then we'll pass back the read version of that DTO. So I'll call this create command for platform. And what we're expecting we're expecting again the platform ID and also a command create DTO. I'm just going to call that command DTO. All right, so again, in our route, we're expecting the platform ID, which we are going to get from here. And again, we'll need to perform this same check. And we're also going to expect a command create DTO in our body payload. So again, very similar check. I'm just going to copy this one, in fact. Console write line and our platform check. We'll pop that in here. All I want to do is just change the name of the action result. So hit create command for platform, will pass through the platform ID, perform the check to see if the platform exists. If it doesn't exist, then we return a 404 not found. If it does exist, then we keep going on. So next thing we want to do is create a variable that's going to, not a car, a variable that holds our command model. So var command equals, and we're going to use mapper to map to what type? To a platform, not a platform, a command. We'll need to bring in that namespace using command service model. So yeah, we want to create a command object that's going to hold a command model. And what is the source? The source is going to be our command create DTO here. I'll paste that in here, like so. Fantastic. Now, just a little shout out here, do a control B. You'll remember our command create DTO. We did specify some required parameters. Fantastic. So one of the nice things about using this API controller declaration is that when we hit this action result and we pass in a command create DTO, there's a bit of a validation check using those annotations to make sure that we have those two attributes. You can probably pass in other stuff as well, but this action result will go back with an error if we don't do that. So that's why, number one, it's very nice to annotate create type DTOs, and it's also nice to put in that API controller stuff at the top because you get all that out of the box. Very nice. So we can the point I'm making is we can kind of be sure at this point when we're doing this mapping that we've got a valid object. You could additionally, if you wanted, put this in a try catch block if you wanted to be super careful, but I think we'll be okay for now. Want to keep the code a bit light. So we've got our valid command. We now want to make use of a repository and call create command on it. And we pass forward the platform ID and then the command object itself. And then we always have to call save changes. Otherwise, that will not be pushed down to our persistence layer, in this case, our in-memory database. And then the last thing we need to do, as we've said here, we want to pass back a command read DTO in the body payload, but we also want to pass back the URI, the resource URI, to this resource as well in our headers collection. So that's where this created at route stuff comes in. But before we do that, we want to actually create a read DTO. So var, I'm going to call this command read DTO is equal. I'll use mapper again. You can see how useful automapper is. We're using it all the time. We're going to use it even more going forward. So we want to map to a command read DTO this time. And the source is a model, which is our command that's being created. Now, because we've hit save changes and our model is being created in our database, this command object now has an ID as well. So we have that at this point. So this command read DTO has a valid ID. I'm just going to capitalize the R just to keep things consistent. All right, fantastic. And then finally, we use our created at route command, which again is a little bit convoluted, but nonetheless, you've seen it working before. So created at routes. The first thing we're going to pass in is the name of the endpoint that will host our resource. So in that case, it's name of, and the whole reason we gave this method a name was so we can reference it. So we'll copy this and we'll paste it into our name of method here. Fantastic. And I'm just going to take a new line because this is going to get a little bit busy. And tab in, and then we're going to do new platform ID equals platform ID, command ID equals command read DTO ID, and then finally we'll pass back our command read DTO as well. Okay, so as part of the resource, we need to pass back both IDs for both our platform and our command. All right, I think that should be good, and that returns a 201, obviously. Now again, we can't test this right now. We can test it to some extent to see if we hit this. So let's see if we can do that at least. So save off, and then we'll bring up our command line, and we'll do a .net run. Fantastic, and then we'll bring up Insomnia. Come over here again, and yeah, within our command service and our local dev, we're going to create a new request. So new request, and we're going to call it create command for platform. Great, and that's a post request, and the body will be JSON. So we'll create that off. I'm going to copy the URI from this one here, this request here, because it's going to be exactly the same URI, just a different verb. Fantastic. And then we're going to pass in a command create DTO. So how to, let's say, build a .NET project. And then the other one is command line. And we'll be quite familiar with this now, .NET build. And assuming, you know, platform 1 was the .NET framework. Now I'll just check that the payload I've got here is correct. So back over in our project, let's do a control B, look at our command create DTO, and yeah, we've got two parameters, both required, how to and command line. So that should be okay. Let's send this. We'll get the 404 not found, which is fine, but we'll just come back over here and just check, yeah, that we hit our create command for platform endpoint. Fantastic. So that kind of brings us to the end of this section on building up our command service. And to be honest with you, it does pretty much most of the things that I want it to do in terms of acting as an API, acting as a service. But the one big missing gap is the fact that there are no platforms in this service. As I said, we could add another action result in here to our platforms controller and allow us to randomly create platforms. That's totally possible, but that would be kind of pointless because our two services are completely then totally independent of each other. And yeah, what's the point in that? So the whole point that we've been building to is that we want to somehow, when someone creates a platform in our platform service, we want to notify our command service that a new platform has been created and add it in to our command service that way. So that is really what we've been building to. We want to use this event-driven messaging architecture to allow us to do that and allow the services to talk to each other in a kind of decoupled way. But nonetheless, there is still a dependency between them. The command service still relies upon the platform service to give it its commands, which is the right thing because the command service is the source of truth. So we're now moving into more exciting territory. So in the next section, we're going to do a quick review of synchronous messaging. We're going to talk a bit about RabbitMQ, and then we're going to stand up RabbitMQ in Kubernetes, and then we're going to add some code into both our services that are going to allow for asynchronous event-driven messaging. So we've been building to this for the last few hours. We're almost there. So in the next section, quick review of messaging, and then onto RabbitMQ. All right, so let's just do a bit of a checkpoint. It's been a while since we've done this overall solution. So we've been looking a lot at the Kubernetes domain. That's cool. And it kind of maps onto this overall solution architecture to some extent, but this is kind of, in my view, the next level up. So let's just do a quick sense check of where we're at. So we've got a platform service up and running to some extent. It's got a SQL Server database, fantastic. We've developed our REST API, and that's pretty much, yeah, that's complete now. The REST-based API is finished. Our internal microservices domain, you could almost map that onto our Kubernetes cluster if you wanted to do that. We have our API gateway, which is our Ingress Nginx controller. We can externally get in and route to these APIs. And again, here's our command service, in-memory database, REST API, which is basically complete. We're not doing any more on that. So this is basically where we're at. And the problem that we were encountering in the last section when we were trying to test our command service was that we have no platforms in there. So what could we do? Well, as we've already kind of done, we in a few sections ago, we created a HTTP client in our platform service that posted or could post data to our command service. So one option would be to create another action result in our command service that would allow us to create platforms using HTTP. That is a totally possible solution. And in fact, what we've already done by posting a test message is basically exactly that mechanism. Just we haven't gone that one step further and added a platform to our internal database in our command service, but we could do that. I'm choosing not to do that because, again, we've talked about synchronous messaging, we've talked about dependency chains and all that kind of stuff, and the platform service needing to know about the command service. So we're not going to do that. Instead, as we've discussed, we're going to introduce a message bus. And this means that any service can drop things onto that message bus, and other services can subscribe to that message bus. And so all the services really need to know about is the message bus. They don't need to know about or be aware of any other services. So when we create a platform in the platform service, it's going to publish a message onto the message bus, and it doesn't care who's listening for those messages. It's just putting the information out there. It might be one service, it might be 100, it might be none. Doesn't matter, doesn't care. And then on the command service side, yes, we are going to subscribe for those events. So in the sections coming up, we're going to look at RabbitMQ, what it is, go into a bit more detail about that. And then we're going to stand up a RabbitMQ message bus in Kubernetes, and that will be the end of the Kubernetes stuff. And then finally, we're going to come back to both our services and implement the publisher and the subscriber functionality. So there's still quite a lot to do. And then just to kind of round off, actually, we'll leave the gRPC stuff for the moment. We'll come back to that when we finish this next section. So that's it for now. Now we're going to move on and do a quick overview of what RabbitMQ is, and then we're going to move over to Kubernetes and stand up RabbitMQ in there. So we'll do that next. All right, so let's go on to talk about RabbitMQ, which is going to be our message broker as part of our solution, or message bus. So what is it? Well, it's a message broker or message bus. It accepts and forwards messages, to put it in its simplest form. Messages are sent by producers or publishers, and messages are received by consumers or subscribers. Messages can be stored in the queue, so it has some degree of persistence. We're not going to be using that in our solution, so if our message bus crashes, then we lose all our messages. But in production type environments, you wouldn't do that. You would allow messages to persist in the event of any failures. But yeah, it's one of the benefits of it. So the idea is messages are published onto the queue. If your services are overwhelmed and can't actually service those requests, the message broker acts as a buffer for those messages. And then as and when you bring more services online, they kind of chew through the messages on the queue. Exchanges can be used to add a degree of routing functionality. Now, we're going to be using an exchange, but we're not going to be routing, okay? So I've got a bit on exchanges a bit in the next slide, actually. So just to clarify what we mean by that. Not probably that relevant to this video, but if you're interested, it uses something called AMQP, Advanced Messaging Queuing Protocol, as well as some others now as well. But AMQP is kind of the sort of traditional message queuing protocol. All right, so we'll come on to talking about this concept of an exchange, which again is definitely a RabbitMQ concept. So there are 4 types of exchange that it provides: direct exchange, fan-out exchange, which is the one we're going to be using, a topic exchange, and a header exchange. Now, I'm really going to talk mainly about the first 2. I'll briefly mention the third one, the topic exchange, and I'm not even going to talk about the header exchange. It's way too obscure for my liking, so it's not even worth bothering your time with it. So the direct exchange, so as it says in the bullet points, it delivers messages to queues based on a routing key. So it's ideal for direct or unicast messaging. So you've got your message broker, you have your publisher, so that could be our platform service, you have a consumer, that's our command service, you have this direct exchange, you have the queue. The publisher will publish a message. So I've created a new platform. It will also attach this routing key, which will place it onto the particular queue, and the consumer will then consume off that queue. So we're not going to use this method. This is the one we are going to use. So RabbitMQ is the message broker, our publisher, which is our platform service. There can be many queues. We don't really care. I think there's only going to be one in our example, but you could have a number of queues, just don't care. We've got our fan out exchange. The publisher will publish its message onto the exchange. In this case, I've created a new platform, and the exchange will then fan out to every queue that's bound to that exchange. And then any consumer that's reading from a particular queue will get that message. Okay, and so that is what we want. Okay, and if there's any routing keys attached, doesn't matter, they get ignored. So it's ideal for broadcast type messages, and this is the method that we're going to use. The publisher doesn't care who's listening, it's just throwing it out there. Now again, depending on how you build out your microservices architecture, you might want to use different types of exchange. If you do want to maybe do more direct type messaging, that's entirely up to you. And maybe this fan out exchange isn't maybe the most appropriate use case for something you're building. But for what we're doing, it's the simplest one. It's the one that we want to use. It keeps our pipe simple, stupid, doesn't do anything. It just basically delivers messages. And that's really what we want. And we build the intelligence into our endpoints. And then finally, we come on to this idea of a topic exchange, and it's kind of almost like a cross between the last two exchanges. Basically, the publisher routes messages to one or more queues based on a routing key. So again, you're using this concept of a routing key used for multicast type messaging. And yeah, it's basically, again, it implements different types of publisher subscriber type patterns. All right, so again, I don't want to use routing or anything like that. I want to just use a kind of, broadcast type message. And that's it. So I think all we really need to be aware of is this fan out exchange. That's what we're going to be using. And so next we're going to stand up our RabbitMQ server in Kubernetes. And then after that, we're going to start working back with our services. So let's move on to doing that. All right, so we're going to come on now and deploy our RabbitMQ instance to Kubernetes. Now, maybe before we come on to writing up our deployment file, let's just check in on our architecture, our Kubernetes architecture. And we've come pretty far. We're almost there. In fact, yeah, this is the last thing we need to do. You'll be quite pleased to hear regarding Kubernetes because it's been quite a long road to travel. So yes, we're going to set up a RabbitMQ container with a cluster IP. I'm not shown on here. We are going to set up a load balancer that will allow us to access the instance externally. Now we're going to use that to look at the actual container itself, but I'm also going to use it to allow our services to connect to it locally from, doing a .NET run. We're going to connect to it that way from our development environment rather than waiting until we deploy it into Kubernetes, the services that is, and seeing if they connect in and stuff. We're going to do a bit more testing before we do that, unlike what I did with SQL Server. It'll probably save us some time in the long run. Now, the other thing I wanted to say here is we're going to take quite a simple approach to deploying RabbitMQ in Kubernetes. We're going to set up one instance with no persistence. Now, if you go to the RabbitMQ website and you look at how they recommend to deploy RabbitMQ in Kubernetes, they take a very different approach. Now, it's all very well documented, but it's quite a long, detailed process, and it's very much aimed at a production type deployment. And again, for me, it's coming into this realm of, as a developer, I'm probably not going to be wasting too much time. Waste is probably the wrong word, but spending too much time on creating clusters of RabbitMQ message buses and making sure they have persistence. That for me is outside the realm of my personal remit as a developer. Great if you get time to do that stuff. I generally don't. So all I really care about is that, is there a RabbitMQ server there? Yes, there is. And in our case, we will have one. Just be aware, this is not a production quality or production class deployment. But what we're doing, it's totally fine, but just calling that out. So back over in our K8s project, just get that up. We're going to create a new deployment for our RabbitMQ instance. So right click, new file, RabbitMQ-depl.yaml. Okay, and the API version, let's get started. Version is apps/v1, and double check everything that you are typing in here, because one mistake and it will go critically wrong. Do you know what I mean? So kind as deployment, and we'll probably put a lot of stuff in there, so I want to take that out. Deployment, that looks right. Specify the metadata, which is effectively the name of our deployment, and I'm going to call it RabbitMQ-depl. And when you do kubectl get deployments, this is the name that appears. All right, so back to top level, we're going to specify our spec and tab in, and we're going to specify our number of replicas. Here we're going to specify 1. Then come on to the selector stuff, and then tab in for match labels and app, and we're going to call this RabbitMQ. That's all. Take that off. New line, bring your cursor underneath the selector, and we're going to specify our template now, and more metadata. Tab labels, and then app. And it's going to be exactly the same as what we specified here. So let's copy that in, like so. New line, and I'm going to specify a container spec, so put the spec underneath the metadata. It's auto-generated containers, yes, which is correct, name, which is correct. So I'm going to call this RabbitMQ as well. So again, these 3 elements here should all be exactly the same. And then specifying the image, and this time it's RabbitMQ:3-management. And now I'm just going to check the way I've spelt management, because it's a word I frequently spell incorrectly. Now this is just the image that Kubernetes is going to pull down from Docker Hub. The management part relates to a management interface, an optional management interface that we can have. So we're going to pull that image down. And we'll use the management interface just to make sure, number one, that we can access it and it's working. And we'll also see messages dropping on to the message bus as well. And then finally, for our specification of our image, we need to specify 2 ports this time. So ports, tab in, and the first one we want to specify, we'll specify the container port. Get this right, it's 15672. That's the management port that we're going to connect in on. And we need to give it a name. As we have 2 ports, we definitely need to give it a name. So I'm going to call it RBMQ-MGMT-port. Come out again, I'm going to specify our second port, and it's a container port again. And this time it's just 5672. So the same as the management port, except it doesn't have the trailing one. And we need to give it a name as well. So I'm going to call RBMQ-MSG for messaging port. And this is the port that our clients, our services should I say, are going to connect in on. This is just for us to access the web interface. So that's why we have 2 ports there. That all looks good, so let's save that off. Now, again, we need to specify a cluster IP for this. So new line, 3 dashes to separate the config. Looking good. So what I'm going to do is I'm going to come over to our SQL Server deployment. I'm going to copy the cluster IP definition. Now, obviously, we need to change it for RabbitMQ, but to save me typing all this again, we're just going to go through it line by line and change the things that we need to change. So API version v1, it's a service. We're going to give it a name, so we do need to change this. So I'm going to change it to RabbitMQ cluster IP service. Coming down to our spec section, the type is cluster IP, the selector we need to change. So we're going to change it to match this value here. I'll copy that down and put it in here. Fantastic. And then we come on to specifying our ports. All right, so I'm going to rename our first port, and this will be our management port. So I'm going to give it the same name as this here. It doesn't need to be, but I think just for clarity, I'm going to give it the same name as that. Protocol is TCP. The port is not 1433, it's going to be 15672, and the target port is also going to be 15672. All right, fantastic. So again, just make sure you get these numbers correct. Very easy to type numbers in wrong and get them in the wrong way. I've done that many times before. Especially with SQL Server, I've often specified the port as 1443 as opposed to 1433. That's caused me no end of problems in my life. So try and avoid stuff like that. And then we do need to specify the second port. So again, we're going to give it a name, and this is for our messaging. So I'm going to copy that as well. Paste that in here. I'm going to specify the protocol again. Likewise, it's TCP. And then we specify the port. This time it's 5672. And then the target port is also 5672. So again, I'm just going to highlight this and make sure I get highlights in all the relevant sections. That looks pretty good to me. I think that all looks fine. Fantastic. So save that off. And then the final thing we want to do is create our load balancer. So again, I'm going to come back over to our SQL Server instance. I'm going to copy the config and we'll go through it again line by line. Just saves me typing it in again. Saves you typing it in again. So again, API version v1 is a service. Metadata will change the name to RabbitMQ. Load balancer, the type is a load balancer. The selector, again, we want to change to RabbitMQ. And then we need to specify our ports in the same way. So you can see here we didn't actually name our port for SQL Server simply because we only had one, but this time we do want to give it a name because we have two ports. So I'm going to specify that first. Name, and I'm just going to give it the same name as this management port up here. I'll specify a management port first, copy. Now again, you can see this Kubernetes definition stuff can get really quite long-winded and quite repetitive and all that kind of stuff, but there's not really any getting around it. So this is the last stuff we have to do. So take comfort in that. So 1.5, unless you enjoy this kind of stuff. Some people like this type of stuff. I personally don't. It's so subject to error. Anyway, so a load balancer, we're specifying our ports. That all looks good. So we've got a name, protocol, port, and a target port. And then finally, we just need to specify the actual messaging port. So we'll give it a name, same name as this. Copy. Protocol is TCP. Port is 5672. And the target port is 5672. Fantastic. So again, just highlight this, make sure we get highlights in the relevant areas. I'll highlight this and make sure we get the highlights in all the relevant areas. That looks pretty good to me. All right, so maybe take a quick pause there. We'll save the file, and in the next section, we will run our deployment, see what we get, and then we'll try and connect in and make sure our instance is running. So we'll do that next. All right, now for the moment of truth. So back in our K8s project, let's bring up a command line. Let's just do a quick directory listing so we can see our RabbitMQ deployment file. Let's just do a quick check, because it's been a while. Do a kubectl get deployments. Just to make sure. Don't know what was going through my head there. kubectl get deployments. Okay, everything's running. Let's do a get pods just to make sure everything's okay. Everything's running, everything's looking good. That's all right, fantastic. So clear the screen and the usual kubectl. Apply F, actually I've done it again. Let's do a listing so I can see the file. Yep, okay, so kubectl apply -f and then the name of our RabbitMQ deployment file. And this is where we find out if we've done anything wrong. All right, so that looks good. So syntactically, it's all passed. So we've got a new deployment created. We've got two new services created. So let's do kubectl get services. And we should see, that looks horrible on the screen. Let's just pull this over. That's better. Actually, do a control B, that's better. You can see here we have our two RabbitMQ services. So we've got our load balancer, and we also have our cluster IP, which is our internal stuff. Fantastic, that looks good. So let's do kubectl get deployments again. We'll see how our deployment's going. So it's saying 0 of 1 is ready. So let's check our pods. So it's doing a container creating, so we'll just sit back and have to wait for that. So I presume Kubernetes is pulling that image down from Docker Hub. So we'll just have to wait and see what happens there. And I'm hoping and assuming and expecting that it should run and start okay. So it's running okay. That's cool. But again, I have fallen into the mistake of assuming everything's okay, and then you do another get pods and you see it's errored out. But that looks okay from my perspective. So let's just come over to Kubernetes and have a quick look. Pull this over and take a look. And we can see that, where is it? There we go. Hiding down here, that we've got a RabbitMQ container. It looks like it's started up quite successfully. Fantastic. So now what we can do is we can, using our load balancer, we can check to see whether we can access the management interface. So let's just bring over web browser using Firefox. Going back to Firefox, actually, I like Firefox. So localhost, and we want to go into our management port. So 15672. Excellent. So we have got our management interface. Now to log in, it's guest and guest. So we just click login, and you can see here we have logged in. It's all looking pretty good. So that's our RabbitMQ service up and running in Kubernetes. What we're now going to come on to do is revisit our platform service and write a publisher service to publish messages onto the message bus. So we'll do that next. All right, so with our RabbitMQ server up and running in Kubernetes, so available to us in our production Kubernetes environment, but also via our load balancer available to us via localhost, we can now move on to updating our platform service. Now, just so we're clear on what we're doing in the next section, or this section, I'll just bring this up again. So we've got all this up and running. We've just stood up our RabbitMQ message bus, and now we're coming on to working with the publisher component of our platform service, asynchronous client to publish messages onto the message bus. So over in our platform service, make sure you have the right project opened up. The first thing we need to do is add the necessary RabbitMQ client packages into our project, because we don't have those yet. So it's .NET, add package, and it's RabbitMQ.client. So we'll add that in, assuming we've typed it in correctly. I don't think I've typed it in. .NET add package, MW. There you go, RabbitMQ client, there you go. Again, that's why it's always good to have this up, because you can actually see it being added in. Sometimes I don't necessarily pay attention to the output down here. It didn't really look too much of an error. So yes, definitely added RabbitMQ client in. Excellent, so that's the first thing we need to do. And then the next thing we need to do is we're going to set up some config. So when our platform service starts up, it's going to connect to our RabbitMQ message bus. Now it needs to know where to connect to. So it's going to be one thing in development, and it's going to be another thing in production. So we're going to update both our app settings JSON files here. So let's do development first. Let's put a comma at the end of this, and the first attribute we're going to set up is RabbitMQ host. You can call this anything you like. I'm just going to call it RabbitMQ host. And in our development environment, that is going to be localhost. Exactly the same as what we did here. And then the second bit of config you want to provide is the RabbitMQ port. And the port in this case is 5672. That's the message bus port, so 5672. And we'll save that off. And I'll do an Alt, Shift, and F to format our file. Save that again. Fantastic. So I'm going to copy this now, and I'm going to copy it and put it into our production file as well. Now, of course, this is not what we will be using in production. That will not be correct. So in order to get what we need to use, let's come back to our K8 project, into our RabbitMQ deployment file. And as before, we have our cluster IP service here. It is the name of our cluster IP service, acts as the name of the server effectively. So we'll copy that. And you've seen that before with how we've used SQL Server. So again, making sure you're in the right config file in production, you'll paste that in like so. So that's our config setup, and we'll read that in obviously when the service starts up. And we've got two different settings for both production and development, which is exactly what we want. So next, what we're going to move on to is we're going to create a new DTO for when a platform gets created in our platform service. We then want to create a DTO for publishing onto the message bus. And you'll see why in a minute, why we have a separate DTO for that scenario. So we'll move on to that next. All right, so let's just review the DTOs that we have. We're still in our platform service and come back to our DTOs. We have two. We have a platform read DTO, which is the DTO we expect back from this service. And again, it's got some kind of domain specific fields like cost and so on and so forth. And also our platform create DTO, which is the one that, we expect when somebody's going to create a platform with us. But we're going to create another one and we're going to call it platform publish DTO. And the whole point of this DTO is that is the DTO that we're going to put on to the message bus. When a new platform gets created, as far as our service is concerned, our platform service, we're going to publish that information onto the message bus, but we're going to publish it in a very specific format. We're not going to include the cost, for example, and we're going to include an additional attribute. So it's exactly what DTOs are meant for, specific scenarios in relation to how we're moving data around our application. So all will become clear when we come to maybe starting to use it, but as a foundational piece, it's the next thing that we need to do. So in our DTOs folder, make sure you're in the platform project, right click, new file, and I'm going to call this platform published DTO.cs. And then again, we're going to specify a namespace. Back in our platform service, we're in our DTOs folder, and it's just a public class called platform published DTO. So what do we want to publish? What information do we want to publish? And I'll just make sure I've spelled this correctly. Platform. Okay, that's definitely correct. Platform. Yeah, cool. That would have caused me some issues a bit later on. So yeah, platform published DTO. What information do we want to publish onto the wire? So the first property is going to be our ID, which is an integer. So this will be the ID as far as the platform service is concerned. We're going to publish the name of the service, and we're also going to publish another string, which I'm going to call the event, the specific type of event. And you'll see how that gets used a bit later on, although I'm sure you can probably guess how that's going to be used. Now, with our DTO being created, we now need to come back into AutoMapper, into our AutoMappers profile, and create another mapping. So the mapping is going to be as follows. Create map. The source this time is going to be a platform read DTO, and we're going to map it to our platform published DTO. And the reason for that is ultimately the trigger for our event is going to be in our controller, in our platform create action. So we create a new action, it gets created. We're going to ultimately create a model in our database. We're also going to pass back the platform read DTO to our consumers, but we're also now going to put a platform publish DTO onto the message bus. So we're going to have already a platform read DTO. We just want to map that onto a platform publish DTO so we can push it out over the wire onto our message bus. So we have that mapping there. All right, fantastic. So I think that's the DTO side of things done. We're now going to move on to actually creating our asynchronous message bus client. So we'll do that in the next section. All right, so back over in our platforms service, let's just close down all this stuff. And we're going to do a little bit of setup. Well, we've done our setup, but we're going to create our interface now. So we're basically going to create a message bus client. But the way I want to build it is, again, we want to use dependency injection. So we're going to have an interface that specifies the methods that our message bus client can perform. And then we're going to build a concrete class to service that interface. So back over in our project, we're going to create a new top level folder. So in the root of the project, new folder, and we're going to call this async data services. So you'll remember we had asynchronous data services with HTTP for our HTTP command, we're now going to create some asynchronous data services for our RabbitMQ message bus. So in here, we're going to create a new file, and I'm going to call it iMessageBusClient.cs. And we'll just make sure we spelled message bus correct. iMessageBusClient. That's cool. All right, so again, this is just our interface. So actually it's going to look very simple. So namespace, and this interface is actually agnostic of RabbitMQ. It doesn't rely on RabbitMQ namespaces or anything like that. So namespace is platform service, and it's now a new namespace, so ASYNC data services. And it's just a public interface called iMessageBusClient. And we're going to define a new method, void. The method is going to be called publish new platform. And it's going to expect as an input the platform published DTO. Fantastic. So all we need to do really is bring in the namespace for our DTOs. So again, that's it. That is our interface. So we're going to expect to use this message bus client, and this method is saying that we're going to publish any new platforms onto our message bus. Fantastic. So save that off. And then next, we're going to come on and we're going to implement a concrete implementation using RabbitMQ. Now, fair warning, there's a lot of stuff in this class. This next bit is going to be quite long, and again, it's possibly prone to some error, so we'll need to take it quite slow, quite detailed, and we'll go through and build up step by step. So yes, we'll move on to our concrete message bus implementation class next. All right, so back over in async data services, right click, new file, and we're going to call this message bus client. Fantastic. So let's start building this monster up. It's actually not that big, but it's probably the biggest kind of class we've got in our application. So namespace, platform service, and we're in async data services. Fantastic. And it's a public class called message bus client, and we want to implement iMessageBusClient to implement our interface. So control period to implement our interface, and of course it's not fully implemented, it's just a placeholder, but that's okay. And I'm going to do a control B just to give us a bit more room. Now before we actually come on to implementing this method, I want to implement a constructor, a class constructor, and it's within the constructor that we're actually going to set up the connection to our message bus. So CTOR, message bus client, and into this I want to pass an iConfiguration object called configuration, because I want to get access to our config elements that we just specified in one of the previous sections. So let's bring in the namespace for this. And again, be really careful. We don't want automapper configuration. We want Microsoft extensions configuration. So make sure you bring in the right namespace. That has caught me out before. Now again, iConfiguration is one of those things that's just available to us all the time throughout our application. So we don't need to specifically register it in our startup class or anything like that. We just have access to that as a matter of course. So we want to then specify a private read-only field to store or to access our configuration. So underscore configuration equals configuration. We won't bring in the namespace, we will generate a read-only field. Again, you've seen this stuff 100 times already now. Now this is complaining, and I'm just going to do a control B. So I just want to check to see what the issue is here. I think it's because this has got a capital L. Let's see if that makes any difference. That's better. Small things like that can drive you crazy. So I thought maybe the file was named incorrectly, but as you could see, the constructor name didn't match the class name because of the mismatched capitalized L. So just be careful that things like that can drive you kind of nutty. All right, fantastic. So that's the first part of our constructor setup, but again, we're only a small part of the way there. So the next thing we want to do within our constructor, again, as I say, this is where we're going to set up our connection to our message bus. We want to set up what's called a connection factory. Now this is a RabbitMQ concept, not dissimilar to a HTTP client factory, similar sort of idea. Allows us to create connections basically to our RabbitMQ instance. So I'm going to create a variable, I'm going to call it factory. I'm going to make it equal to a new connection factory. And we're going to have to bring in a namespace, control period, using RabbitMQ client. So it's a RabbitMQ concept. All right, and then we're going to define what our configuration elements are, what our connection stuff is. So the host name is going to be equal to, we're going to access our configuration instance, and then we're going to specify the name of our configuration element. So control B, and we're going to come down to either one of our files because we've named them the same thing. Now that's a really important point. These have got to be named the same thing. So RabbitMQ host and RabbitMQ host. The values are of course different. So we want to inject in our host value into here. So control B, and we'll paste that in here. That's the first part. Okay. And then we want to specify the port. Now the port value is an integer. Now we have stored our configuration element as a string, not a problem. So let's build up step by step. So we're going to access our configuration and we're going to access the port element. So we come back over here, we'll copy this, bring it back here and paste that in here. Now I'm just going to move to the end of this. It's getting a bit long, so maybe I take a new line, maybe that's what we do. And I'm just going to put a semicolon at the end there. Now this is not going to work because we are expecting an integer, so what we're going to do is we're going to say int.parse, and then we're going to wrap that in a pair of parentheses. And that should stop erroring out. Fantastic, so let's just save that off. Just do a quick build, just to make sure we're on the right track, because we say we've got a few steps to go in this class and I want to make sure we're not making errors as we move along. So that's all looking pretty good at the moment. Fantastic. So we've got this factory, connection factory object now that we can actually build connections off of. So this next set of stuff we're going to put into a try catch block. So try, because obviously stuff can go quite wrong here. Catch, we'll catch the exception. Call it EX, and then in here, right line, and we'll write out something. We'll use string interpolation, so $, double quotes, put the semicolon at the end, and we'll just say could not connect to the message bus. And we'll put the exception, put a colon there, and put the exception in here so we know kind of what issue we have, and it's more than likely going to be the service isn't available, the RabbitMQ bus isn't available, something of that nature. Alright, so we've got a little bit of setup to do now in our try block. So the first thing we actually want to set up is a connection. So what I'm going to do is I'm going to create a private read-only field called connection. And I'm going to make that equal to a factory, and I'm going to call the create connection method on that. So of course, control period, and we want to generate a private read-only field. We put that up there, and that's added up to the top. So this is our connection now. The next thing we want to do, and again this is RabbitMQ specific, is create something called a channel. So underscore channel. And that's equal to our connection, and we do something called create model. So again, the way RabbitMQ works is kind of, again, it's a bit like Kubernetes, it's multi-layered, there's multiple things we have to set up. We have to set up a connection, we have to set up a channel, and then we have to set up an exchange. So again, just the way it's architected. So again, we'll create another private read-only field for our channel, so generate read-only field, and again, make sure it's being added up here. Next thing we want to do, off of our channel, is declare an exchange. So we're talking about fan out exchanges, direct exchanges. This is where we declare our exchange. So exchange declare, and into here, we'll use exchange. We'll give it a name. I'm just going to call it trigger, as we're triggering messages. And then we specify a type. And this is where, actually put the colon in, our exchange type, and we specify, you can see the different types here, we specify it's a fan out exchange. Okay, so we've got a connection, we had to create a channel off of our connection, and now we're now declaring an exchange off of our channel. And at this point, really, we should be pretty much connected to our RabbitMQ instance. But what I'm also going to do, because we might use it at some point on our connection, we're going to subscribe to the connection shutdown event, because we maybe want to do some stuff in there. So we'll subscribe to that event, and I'm just going to call it RabbitMQ underscore connection shutdown. Now this doesn't exist yet, so we'll just come outside of our constructor, and down here we will just declare that private void, copy the name, we'll get the object sender. And again, if you've not worked a lot with events before, this is basically an event will be triggered when the connection shuts down, and we can put anything in this method here, basically, when that event triggers. I'm not actually going to put too much in it. In fact, I'm going to put nothing in it for the moment, but we may come back to it at some point. Well, I'll tell you what we will do. We will put in a console write line just to say that our connection has been shut down, just so we're aware that that may have happened, and it helps us debug, doesn't it? So write line, and we'll just say RabbitMQ connection shutdown. Okay, so if you don't want to put this in, you don't really have to. I'm just putting it in just to be a bit more kind of, yeah, it gives us a bit more detail if something does shut down. But at this point, we should be connected to our RabbitMQ instance. So again, I'm going to put console write line, and we'll say connected to message bus. And we'll save that off. Fantastic. Okay, so that's our constructor done. That's basically our connection done. So the next thing we want to move on to, which we will do in a second, is basically create our publish new platform message. So we'll do that next. All right, so on to publishing our platform, actually implementing our main method here. So let's get started. So we'll take out the exception that we've got there. The first thing I want to do is create a message object. And that message object is basically going to be a serialized version of our platform publish DTO. So we're going to use JSON serializer. I want to bring in a namespace for that. So again, use system text JSON. And we're going to call the serialize method. And what are we going to serialize? We're going to serialize our platform publish DTO, because we're going to send it over the wire. And ultimately, we're going to convert it to a byte array. All right, so got that as a string now, basically a serialized string. And then all this method is going to do is going to check to see if our connection is open. And if it's open, then we're going to actually send it. And I'm going to put the send functionality into a separate method. So we'll leave that blank for the moment. Well, I'll tell you what, we'll put a console write line in just to help us with debugging. So console write line, and we will say RabbitMQ connection open sending message. ... Fantastic. And if the RabbitMQ connection is not open, then we'll do a console write line saying RabbitMQ connection is closed, not sending. Now we could start getting into retries and all that kind of stuff. I'm not going to implement that today. It's just going to take too long, but we'll just write out a message for now to say that we were unable to do that. So we will come back here and put a bit of a to-do in. You still have to actually send the message. Now we could put it in here, but I just feel it's a bit cleaner to pull it into a separate method. So I'm going to make it a private method. Void, I'm going to call it send message. And we're just going to expect a string of message type. Now the other reason I'm doing it this way is that we are exposing this publish new platform as a method on our interface. It's conceivable we're going to have a number of different methods, so publish platform, publish something else, whatever it happens to be. So this send message method, I want it to be generic, reusable by any other methods, and we may just have, you know, a range of other methods that we expose to do other specific things. So that's the other reason I'm kind of pulling it out into its own method. Send message is just totally generic. So I want to now create the body of our message that we're going to send, and it's going to be a byte array effectively. So var body equals encoding. I'll bring in the namespace, system text, and then we'll say UTF-8, get bytes, and then we'll pass in our message. Now while I remember, I'm going to come back up here, and I'm actually going to call send message from in here, and we're going to pass over our message that we constructed up here, our serialized message, just in case I forget, which I probably will. So that's this method finished, and now we're just going to complete our send message method. Now all we actually have to do now is on our channel, we just need to publish our message. So we'll call the basic publish method. Here we are. And we have to specify the exchange, which we called, when we declared it up here, what did we call it? Trigger. So this is possibly something you'd want to pull into config as well. You don't really like to have magical strings in our code, but anyway, we'll brush over that for the moment. Get rid of this. The next thing we need to specify, which we are going to ignore, is a routing key. Now you'll remember fan out exchanges ignore the routing key anyway, so it's just going to be nothing. Okay, these tooltips can be useful, but they can also be quite annoying. I find sometimes the tooltips appear when you don't want them, and they don't appear when you do need them. Next thing is basic properties, and that's just going to be null. And we keep getting that, quite annoying. Our body is going to be our body that we've declared here. And that is basically it. Okay, so basic publish, what exchange are we publishing it on? Routing keys are relevant anyway. Basic properties we just set to null, and the body is what we've encoded here. And then really, at that point, we can say console write line. And we'll use string interpolation, and we'll say we have sent, and we'll put in our message here. Fantastic. So that is pretty much it. The only other thing I want to put in is a dispose method. So when our class dies, we clean up anything that's left behind. So public void dispose. I'm just going to do a console write line because I like to understand when these things are happening, and we will say message bus disposed. And we'll just check to see if the channel is open. And if it is, then we will just close the channel off. And then we'll close our connection off as well. Fantastic. So I think that is us done. So let's just do a quick .NET build. And we're all good. Fantastic. Now, before we move on to actually using this now, one last thing I want to do, because it's the thing I'm tending to forget at the moment, is we want to come over to our startup class and we want to register for a dependency injection our iMessage bus interface and the concrete class. So back down in startup, let's get rid of that. Come back up to configure services and let me just get rid of that so we get a bit more room. And after our HTTP client, let's add a registration for asynchronous client. So this time we're going to add a singleton. And the idea of this is that we're going to use the same connection throughout the rest of our application, so we add a singleton lifetime basically, is why we're doing that. And we'll add an iMessage bus client of type message bus client. All right, and let's just bring in the namespace. Oh, my butterfingers there, so control period, and yeah, using platform service async data services, and that should resolve them both. In fact, it does. Fantastic. So that should be our asynchronous data client setup, which is rather exciting. So now what we want to do is we want to use it from within our controller. So when we create a platform, not only are we going to still send a synchronous message to a platform service, which we're still going to do, we're now going to drop a message onto our message bus. So we're getting towards asynchronous messaging between our services. So we'll do that in the next section. All right, so we're almost at the point, well, we are actually at the point where we can use our message bus client now. So we're going to do a control B, make sure I'm in the right place, and we're going to come back to our controller. So let's do a quick review of our platform's controller. So control B, again, let's come up to the top. So we have our constructor and we're passing in a repository, fine, our mapper, fine, and also our synchronous data client, or HTTP data client. And down in our post action result, where we're creating a platform, we're doing all our usual create platform stuff, but you'll remember down here, we then actually attempt to send a message to our command service using HTTP. All right, so we're now going to put in another component here where we're going to send a message asynchronously. So back up to our constructor, we're going to add to the things that we are passing in via our constructor using dependency injection. So this time we're going to pass in an iMessage bus client, and that's going to be equal to, it's going to be called message bus client. And we need to put a comma there. And we should bring in the namespace. So yep, using async data services. Fantastic. And then down here, we're going to create a private read-only instance of that. So message bus client equals message bus client. You've seen this 1,000 times before now, and we'll generate a private read-only field. Super. And that's why, of course, we had to, again, I'm just laboring the point, we had to make sure we registered this here. That's something I usually always forget, but we've done it this time. So back down into our create platform method, what I might do, although it's obvious, although you can read it in the code, I might just do a little bit of documentation and say send sync message. And then under here, we're going to send our async message. All right, so again, we'll put it in a try catch block because it's something that could conceivably go wrong, and we'll deal with our catch first. Oh. So we'll catch an exception, EX. I'll do a console whiteline. I might just copy this here. Saves me typing. And we will just say could not send asynchronously. There we go. So the first thing I want to do in here is create a published DTO. So we created our published DTO. We want to map into, well, we want to create one basically. So we'll call it platform published DTO. And that's equal to mapper. Map. What do we want to map to? We want to map to a platform published DTO. And what is our source? Our source is going to be our platform read DTO that we have up here, hence the mapping that we created. So you could create other mappings. You could conceivably create the mapping from, rather than mapping from a platform read DTO, you could map from the model. That's a possibility as well. Up to you how you want to do it. Now you'll remember, if we just do a Control B, over in our, let's have a look at the details, in our platform publish detail, we had all this stuff here, fantastic, but we also had this property called event. Now that is not, event is not available as part of our platform read detail, so we need to explicitly add that in. And that's just to help us identify at the other end what type of message event has been sent out. So platform published detail, we'll find the event property and we will just make that equal to platform published. Now you would probably want to have a kind of, you would want to document the events that this service emits. In fact, within your entire microservices architecture or application, you would want some kind of documented library of the events that can be expect to be sent and received along with the payloads and all that kind of stuff. I'm trying where possible to keep the payloads as standardized as possible. All right. And then finally, moment of truth, we use our message bus client to publish a new platform, and we just send that one to the wire. Fantastic. So we are almost at a point where we are going to test this. So I'm just going to save that off. And in the next section, we are going to test this. We'll spin up our, and we'll test it locally. We'll spin up our command service locally. We'll spin up our platform service locally. We should see it connect in when we send, see it connect in, and we should see it send a message once and only once we create platforms using the controller. So we'll do that next and see how we go. All right, so let's run up our platform service. So .NET run. Okay, so let's just take a quick look at the output. Shouldn't be anything different from what we've already seen before. So where is it? Yep, so it's using the in-memory database, which is correct. Our command service endpoint is our command service, which isn't running yet, and we've seeded data. Now, a point to really note here is that we're going to run up our command service now locally for the asynchronous stuff we've just done. That, well, it doesn't need to be there anyway, because again, all it needs to be there is the message bus. So the reason we're running it up is so that the synchronous part of our messaging will still work. And we'll actually shut down our command service as well to see what happens when that is not there and how the synchronous stuff behaves. So we've got our platforms service up and running. Let's come back to our command service. Over here we are. And let's do a .NET run. Fantastic. So again, it's running on localhost 6000, which is good. And then we'll bring up Insomnia. And we will come back to our local development environment, back to our platform service, and we're going to create a platform. Now I might just move this, because we're slightly running out of screen real estate, but let me just do it in Insomnia and we'll see what we get. So let's send this over. So that's cool, we got our 201 created, fantastic. Let's move back over here. So this is our command service, and you can see we've still got the inbound post, which is all that we're doing, fantastic. But more interestingly, if we come to our platforms controller, you can see that we connected to our message bus, which is good. Our sync post was okay, obviously, because we just saw it was received by our other service. And then you can see that the RabbitMQ connection was open and we were sending the message. And then finally, we sent the message, we dropped onto the message bus. So that's all looking really rather good. And you can see here, boom, in our RabbitMQ message bus, yes, indeed, there was a message placed on to the bus. Now, off screen, I've got Insomnia. What I'm going to do is I'm just going to rapidly fire some, you can hear me clicking, I'm going to rapidly fire some events in here. And we'll wait for this to catch up and you'll see how that should manifest. So I've just basically blasted a load of commands onto the message bus. So maybe we need to get this to update a bit quicker. Maybe I do a few more. And you'll just see I've only put a couple on and you'll see how that compares to what we just blasted on. Holding our breath, there we go. So there's a few more. So that's all looking really rather good. So again, we've dropped stuff asynchronously onto our message bus. Our command service is only getting synchronous messages via HTTP. We still have to build in the subscriber. We've not done that yet. But let's come back to our command create service. And you can see here, command service, all the inbound post commands. And I'm going to stop this now. Okay, I'm going to do a Control C. So our endpoint is now down. Synchronous endpoint is now down. Now I'm going to click send, watch what happens. We get spinner, we're waiting. That is because our platform service is attempting to send a command to a synchronous endpoint, and it has to wait for the message to come back to go either successful or unsuccessful. And there's, I'm sure, a default timeout window that we will wait for. Again, just to demonstrate again, it's waiting. Now you can imagine this whole idea of a dependency chain where you have hundreds potentially of services all doing that, how that could stack up and cause massive delays just because that endpoint is not there. What you will also realize though, as we come back to our message bus, once the synchronous messaging component failed, the asynchronous stuff still went ahead and dropped our asynchronous messages onto the message bus, because that's still there and that's still running. So you can start to see the differences between synchronous messaging being problematic if it's not there, and us just dropping async messages onto the message bus. All right, so that is all looking pretty good. So I think what we should move on to next is we can do one of two things. We can either deploy this into our Kubernetes cluster, which I'm probably not going to do. I think what we do next, because this was successful, is we build up the subscriber in our command service so it can actually receive the events from the message bus. So we'll move on to that in the next section. All right, so let's make sure we are over in our command service, and I'm just going to, before I do anything else, make sure everything else is shut down. Let's just shut that down as well. Okay, so back over in our commands service. Now, I'm going to give you a bit of warning here. This is actually by far and away the most complicated part of the whole video. And that is basically allowing us to, number one, subscribe to the message bus, and then two, determine the event on the message bus, and then do something with that event that we've determined. So there's quite a few things that we need to build up here. So we're going to have to add 2 new DTOs to our command service. We're going to have to add the RabbitMQ config to our config file. So we'll do that next, and that's quite straightforward. You've seen that already. We're then going to define what's called the event processor. And the event processor is basically going to determine what type of event did we get. So again, the RabbitMQ pipe is stupid. We're just getting events. So we need to find a way of determining what was this event. Was it a platform published event? Was it a shipping event? You know, there could be a million different events. So the event processor class is really determining what was this event and then doing something with it. And then we're going to write the class that actually connects to the message bus and receives events, because it's dependent on this event processor. So we have to build it up in the order in which they're used. Okay, so there's a lot here. Conceptually seems quite simple, but the implementation, there's a couple of little really gnarly things in here to do with the way dependency injection works, service scopes, service lifetimes, and we're going to be doing some kind of interesting stuff around getting access to our repository. And there's a lot going on here, so you do need to pay attention. All right, so in this section, what we're going to do, just some simple stuff to begin with. We're going to check that we've got the RabbitMQ client library, simple enough, and we're going to create our config, and then we'll move on to the next section. So, commands service, commands CS proj file. Let me just get rid of this for the second. Make sure I'm in here. And yeah, we don't have the RabbitMQ package, so .NET add package. And it's RabbitMQ. Keep saying MQ client. All right, simple enough. And there we go, that's added in, very good. And then, like we did with our platform service, we want to add in configuration elements to both our production and development app settings JSON files. So we'll do a Control B. And what I might do is I might select our app settings development JSON, and I might just come over to our platform service, and I might just copy in those files. So here we are, platform controller, platform service should I say, and I'm going to close all this down. And we'll come to our development JSON, and I'm just going to copy these because it's exactly this, connecting into the same message bus. Okay, so I'll copy these over. All right, and I'll paste those in. And doesn't like that. I need to paste it inside here. Paste it in here. That's better. I'll tidy that up by doing an Alt, Shift, and F to format our file. Save that off. Fantastic. And then we'll select our. We've only got an app settings JSON file here. That's interesting. We don't have a production settings file yet, so let's do that. So in the root of our project, right click, new file, and we'll create an app settings.production JSON file. And we will come back to our platforms class, platform service, get rid of that, go into our production class, and we will just copy this out. Actually, we only need the 2 elements, so copy that, and back over in here, we need to put in a pair of curly brackets, and this is our config for our platform service. So platform service or command service in production. Okay. All right, so command service, we got our development configuration and we have our production configuration, remembering that it's the RabbitMQ cluster service IP name that we want for production. So that is our sort of basic config setup. Next, we want to move on to doing our DTOs. All right, so we're wanting to create some DTOs now to support receiving platform event messaging down at our command service. So let's just close this down and we are back in our DTOs folder. So the first DTO we want to create is the platform publish DTO. .cs. So again, we're dropping this DTO onto our message bus from our platform service. We want to take it at the command end and use it and add it ultimately to our database. So namespace is command service DTOs, and then it's just a public class called platform published DTO. And what I might do, just to kind of save a bit of time, is come back to our platform service and just copy these properties over into here, as they should be exactly the same. Fantastic. Now, ultimately, what we're going to do is we're going to get this, receive this, understand that we've got this, and we want to then create a model in our command service database. So if we could take a quick look at our models, it's the platform model that we want to create, obviously. The ID is taken care of by our database, so we don't need to worry about that. The name we are getting here. We're passing over this additional event property, which our platform doesn't care about, and we're going to use that for other purposes. But we have specified that we do require this external ID property. Now, what that is going to ultimately be is it's going to be the ID of the platform in our platform service. We're going to use that as the kind of unique global identifier. So we're going to have to map between platform publish DTO and platform DTO. Now, unlike previous times where, you know, in the case of name, it's just a straight through exact mapping. AutoMapper can do that for us without any additional config. In this instance, we are going to have to tell AutoMapper that we want to map ID to external ID. And so this is where the AutoMapper stuff starts to get a little bit more interesting. So before we do that though, let's just create our other DTO. And there's one more, it's a very small one. Call it new file, and we're going to call it generic event DTO.cs. And we'll just create a namespace. Namespace. And that's command service DTOs. And it's just a public class called generic event DTO. And it's just got one property, it's a string, and it's just called event. Now I'm not going to go into the details of why we have this just yet. We'll come on to that a bit later, so just stick a pin in that for the moment. And we don't need to use AutoMapper to map this either. That's just something we use a little bit later. But we do need to come back to creating a profile now and a profile mapping that's going to map our platform publish DTO and map it to our platform model. So we'll do that in the next section. All right, so let's come down to our profiles folder, and in commands profile, we want to add in a new mapping. So we've seen this before, so create map. What is the source? The source is our platform publish DTO. That's what we're going to get over the wire. And we want to map it to our platform object, which all sounds very reasonable. And we'll just close off with a parenthesis. But as I said in the last section, we want to explicitly tell AutoMapper that we want to map the ID of our platform publish DTO to the external ID of our source, of our target, sorry, of our destination. So let's do that. So the way you do that is don't put a semicolon here. You come on to the next line if you want to make it look a bit neater. You can have it on the same line as well, obviously. And we do for member. And then we specify lambda expression, destination. So this is where we want to map to. So we say the destination, which is ultimately a platform object, dest, and it knows that our destination is a platform object. So we want to select the external ID property. We then select some options. So OPT goes to OPT, and I'm just going to do a Control B to give us a bit more room. So we can see what's going on here. And then we want to specify on this option, map from. And then what are we mapping from? We're mapping from our source, which is our platform publish DTO. And what are we mapping from? We're mapping from ID. Okay, and we'll terminate that with a semicolon. And everything else should map through okay, but that is our explicit rule saying at our destination, which is our platform model, we want the external ID to be mapped from the ID of the source. All right, and we'll save that off. So that's our mapping setup. Now, I'm going to preempt something that I want to do a bit later, and what that is when we come and we receive this platform published object, we have to do a lot of stuff before we get to that, or after we get to that. We want to determine that we want to put this model, this object, into our database. Now, we want to make sure that we're not duplicating the same platform in our database. So we're going to do another repository method to say, given an external ID, do we already have that external ID in our list of models? And if so, then we don't add it. So it's very similar to the platform exists method. This one is just slightly different. We're using the external ID this time. So I'm just going to add that to our repository ahead of time, and then we'll use that a bit later in our event processor class. So we'll do that next. All right, so let's just do a Control B and close this stuff down, and we're going to come back to our repository. We're going to use this a bit later, so I'd rather just get this done ahead of time than do it at the point when we need it. So back over in iCommander repo, we already have this platform exists, and that's checking to see whether we actually have a platform with that URI in our database. We're going to create a very, very similar method. Let's call it platform, well, we'll call it external platform exists. And this is just going to be used to check that we're not going to add additional platforms into our database when we already have it there. Okay, and so we'll say int external platform ID. Fantastic, and we'll get an error now on our concrete class because we've not implemented this, and I'll just pluralize that. So external platform exists, that looks okay, fine. And then we'll come over here and we'll just come up to here and do a control period to implement the interface, and that will put it down here somewhere. Where's it gone? There we are, external platform exists. Now what I might do is find our platform exists method and just copy this because it's going to be very, very similar to that. So in here, we'll paste in return context platforms NA, P goes to P, and this time it's not on the ID, it's on the external ID is equal to the external platform ID. All right, so again, similar concept, we're just going to check to see whether we have that, because we do not want to double add more and more platforms if we've already got them, and we're doing that based on the external ID. Fantastic. So just a quick change, and now what we're ready to do is we're going to move on to our event processor class. All right, so on to event processing. So just to give you a quick explanation of what this is, we've got two main bits still to do, and that is the event listener, effectively. We're going to do that later. This one is the event processor. So upon getting an event, which we'll do later, we need to determine what is this event? What is it? Is it a platform published event? Is it something else? So upon determining what the event is, we then want to do something with that. And what we're going to do is we're going to add that platform to our database, assuming we don't already have it in there, hence the last section. So that's ultimately what we're going to do with the event processor. Now, I will call out that we only really have one event that we're interested in our platform. If you had lots more events, then the way I've built this class, you would probably want to decompose it a bit further. But for our purposes, I think it's fine. So back in our command service, let's close everything down. And we're going to create another top level folder called event processing. Now this next bit is actually, there's quite a lot here, and there's a few interesting concepts in it, not most especially around dependency injection. It can get a little bit gnarly. Anyway, so we're going to create an interface first, because as always we're going to use sort of dependency injection. So new file, and this is called event, capitalize the E, processor.cs. All right, now this is actually going to look very, very simple, but behind the scenes there's a lot going to be going on here. So namespace command service, event processing, and then it's just a public interface called event processor. That's right. And it's going to have one method called process event, which seems benign enough, and it's going to take a string called message. Very, very generic. So ultimately we're going to get this message string from our event listener service, which we've yet to build, and it's just going to be our object or event string. So we're going to have to take that string and understand what the heck is this, deserialize it, find what event it is, and then do something with it. So a very benign looking interface, but there's going to be a lot going on behind the scenes. So let's not mess around anymore, let's create it. So new file, still in event processing, and we'll call it event processor.cs. And let's do the easy stuff first. So namespace, command service, event processing, and it's just a public class called event processor, and it's going to implement my event processor. So as usual, let's implement the interface, well, implement the placeholder, but we're not going to come on to that just yet. Now the first thing I'm actually going to do is I'm going to step outside this class, and in here I'm just going to create a very simple enum. So enum, and we'll call it event type. And this is just listing out our event type. So we're going to have platform published and undetermined. Okay, and that's the only ones we're dealing with. And the reason I'm creating an enum is I don't really like working with magic strings, so this just gives us a bit more structure around the types of events that we can have, and you'll see how this is going to get used in a second. And now just make sure you create that outside the class. All right, so we're coming on now to our class constructor, and again, coming back to the intention of this class, it's to take a message, determine what it is, and then we're going to add, if it's a platform published event, we're going to add our platform to our database. So immediately you're going to think, well, that's cool, that's just constructor dependency injection, that's just injecting a repository into this class. Unfortunately, in this case, no, that is not the case. We cannot do that. And the reason is for rather torturous dependency injection reasons. So I did kind of brush over it a bit earlier in the course, but when you register your services in Configure Services, they have what's called a service lifetime. So scoped, transient, or singleton. Now, singleton registered services, they exist for the lifetime of the application, basically. Scoped services, they exist kind of for every kind of session, and then the transient ones, it's every request. So they have different lifetimes. So singleton ones last for the entire length of the application. Fine, you may say. When we come on to creating our listening service, that is going to be created as a singleton service ultimately. It's going to be there for the lifetime of our application. And that service is going to call this service. And in order for that to happen, in order for us to inject this event processor service into our listening service, it too has to have a lifetime the same or greater than the service it's being injected to. So this service is going to have to be a singleton service as well. Fine. If we then try and inject in a repository and ultimately further down the food chain a DB context, those services have been registered with a shorter lifetime, and you can't do that. Freaks out, okay? It's not good practice. So in a long and roundabout way, we cannot inject a repository into the constructor here. We're going to have to inject it, well, we're going to have to create it, a reference to it in another way. So that's what we're going to do here. So coming back to this, probably become a bit more understandable when we actually go through it. So class constructor. So instead of injecting a repository, we're going to inject something called an iService scope factory, and we'll call that scope factory. And the use of the, we'll just get rid of the thing at the side there, and the use of the term factory, you might start to have some idea of what this may allow you to do, or maybe you don't. And I don't blame you if you don't. But the good news is we can still inject our IMapper in, so in the usual way. That's fine. And we'll bring in the namespaces for this, and we'll have to capitalize that. So to bring this in, Microsoft Extensions Dependency Injection and AutoMapper. All right. I might actually just take this back up onto this line. I don't like using multi-lines unless I really have to. So again, we're going to create some private fields. So scope factory equals scope factory, and mapper, or underscore mapper, equals mapper. And then we'll create some read-only fields for these here. Read-only fields, and correct that, and bring in a read-only field for that as well. Fantastic. So we'll come on to using the scope factory a little bit later when we actually do have to use a repository, but stick a pin in that for the moment. So the next method I'm going to create in here is in support of our publicly exposed method, which is process event. It's a private method, and basically this is the method that's going to determine what is the event that we got. And ultimately what it's going to use, if we come back to do Control B and we look at our DTO, we look at our platform publish DTO, we are passing through this event attribute here. And we're going to basically look at that and see what that is. And you will remember from, or maybe you don't, from our platform service over in our controller, when we generated our synchronous message, we set that event to this field here, to this string here. So we're basically just going to ultimately look for this string to see and understand whether it's a platform published message. So back over in our command service, let's get rid of that and let's come back to our event processor. So this is a private method, and we'll call it private event type. So it's going to pass back an event type that we defined here. And we're going to call it determine event. Into that, we're passing the string that we get passed through from our, ultimately from our event listener, and we'll call it string notification message. Fantastic. Okay, then I'll do a console write line. Bring in the namespace for system. And we'll just say something along the lines of determining event. Fantastic. So the first thing we want to do is basically deserialize this string into an object. Okay, so I'm going to create a var, call it event type, and we're going to use our JSON serializer, and we're going to bring the namespace in first before we start to use it. So system text JSON, get rid of that, and we're going to deserialize this time. Now what we're going to deserialize to, well, again, to bring this back up, the reason we created this generic event DTO is we're going to deserialize to this because all we really want to pull out from any message anywhere in our microservices platform is this event property here. So when we deserialize it, we want to deserialize to that. Now, in days gone by, if you're using the JSON, the Newtonsoft JSON library, you could use what's called dynamic deserialization, and that means it kind of does it on the hoof. I didn't like that anyway because you kind of end up with a non-typed message, which I don't like. So this is typed, using dynamic as non-typed, and it leads you into all sorts of crazy madness, which is not, I don't think, best practice anyway. So long and short of it, we're going to deserialize to a generic event DTO. And what's our source? Source is our notification message. So this is really just to enable us to get at that event attribute. And we'll just bring in the namespace for this. And I think I've spelt it totally wrong. Gen-ic. No T. Let's try that. That's much better. Okay, so we have our generic event here. And then all we want to do is just switch on that. So switch. And we'll access our event type and access the event on it. And I'll just move this up, and then we're just going to do some case statements. Case. And I'm going to come back to our platform service and have a look at what we passed over. I'm just going to copy this. And I'm going to paste that in here. So if our event is that, then of course we can be confident we have a platform published event. And I'm going to do a console write line. And we'll say platform published event detected. And we will simply return back event type of platform published. Fantastic. And that's the only sort of switching we're going to do. So we will just round off with a default, and we'll just write console write line. Whoop. And I'll use this, and I'll actually do that up here as well because I've been using it all throughout the application. So let's keep it consistent, and we'll say could not determine event type. And we'll just return with that. Oh, actually, we need to return the event type, which will be not platform published. That will get very confusing. Undetermined. There we go. That's great. Fantastic. So again, the whole point of this private method is just to ensure that we can understand what event we got down the wire. And our process event is then literally going to do something. Well, it's going to see what we got back, and it's going to then action it, do something with it. So we'll take a quick pause here because this video's been going on quite long, and we'll come back and we'll finish off our process event and one other method of this class. All right, so let's come back to our process event, and actually just don't forget to save your work just in case something crazy happens. So in process event now, this is kind of our main publicly exposed method. All we want to do is we'll create a variable of event type, and we'll make that equal to determine event, and we'll pass over the message that we get here. So we've kind of, subcontracted the determination of event to this method here. We now have that in our event type, and then simply we just switch on that. So we'll switch on event type, case. So case event type is platform published. Then we want to do something here, and then we'll break. And then we'll just put a default in, and we'll do, well, we don't need to do a console write line because we already kind of had that from here, so we'll just leave it. We'll just break it. Probably a bit redundant, but we'll leave it like that. So what do? We've got a platform published event. We want to actually add it to our database. That is ultimately what we want to do. Now, I would probably, going forward, move out the kind of classes that we use to action our events. Possibly, I'm not sure I would wrap it into our event processor, but I have for this video, and I feel in this instance it's totally okay. So still within our event processor class, we're going to do one more private method, and I'm going to call it private void add platform. And we're just going to expect in the string, and this is effectively our published platform DTO, but it's still in a string form, so we'll call it platform published message. Okay, now this is where we're going to start using our scope factory to actually get a reference to our repository. So we'll start off with a using statement. Determine or declare a var called scope. Our scope is going to be equal to our scope factory, create scope. All right. So then within here, we're going to create a variable to contain our repository. So we'll just call it repo. And that's going to be equal to our scope, service provider, get required service. And what type of service do we want to get? We want to get an I command repo. Okay, so basically getting a reference to this in this way, as opposed to injecting it through constructor dependency injection. And again, it all comes back to the service lifetime of our repository and this class here. So again, a bit gnarly, but you know, it's definitely useful, and it's going into the more detailed use cases around dependency injection. So the next thing we want to do is not do that. We want to create a variable, and this time we want to essentially deserialize our platform published message into a proper platform published DTO. So var platform published DTO is equal to JSON serializer, deserialize. What do we want to deserialize to? Platform published DTO. And what is the source? Again, this is very similar to the mapping syntax that we use with AutoMapper. We want to deserialize this here. And that's okay, the namespace is already there, so that's cool. So this will then be our platform published DTO. And then finally, we want to try and add this to our database. So I'm going to put this in a try catch block. And so I'll do the catch statement first. And we'll just do a console write line. And we will say, could not add platform to DB. And we will put in our message in here, so EX message. Don't forget the semicolon, which I'm sure you won't at this point. I've been doing quite a lot of coding here. So within our try block, what we want to do is ultimately get a platform model. So multi-stages of converting objects, so var plat equals mapper, not scope factory, mapper. And what we're mapping, we are mapping to a platform. And what are we mapping from? We're mapping from a platform published DTO here, this here, okay. So we'll leave it as is, bring in the namespace for that. And again, semicolon. Great, so we've got our model now. So all we need to do is determine whether we want to add this platform to our database. And that's where this new repository method comes in. So if repo, or if not repo, we'll do external platform exists, and we want to access on our platform object our external ID, and that should have been mapped through. So if it doesn't exist, then we will create it. Otherwise, we will do something else. And in fact, we won't do it. Well, we will. We'll write out a message because we're going down that path, aren't we, of writing console write lines. So we'll do that again. Write line, and we'll just say platform already exists. So we won't bother adding it. Fantastic. And then finally in here, we will do repo, create platform, and we'll pass in our plat object. And then finally, we'll do repo, save changes. Otherwise it will not get added. And I think that is that. That is our event processor class. So, you know, logically it doesn't sound that complicated, but you saw there was some fairly interesting things going on in there. So let's do a .NET build. That's all looking okay. Don't jump the gun. Now the one thing, again, not to forget this, let's put it in. Control B. Over in our startup class, we want to register our event processor interface and our event processor class. So after controllers, we'll put it in there. So using our services collection again, we are going to add singleton this time. And again, the reason we have to do that is because we are going to inject this class into our message bus subscriber class. So add singleton, event processor, and we're going to, let's bring in the namespace, event processing, and then we're going to give them an event processor, like so. All right, fantastic. So we'll save that off. Now what I might just do is I might just run this up, because stuff will often build fine and sometimes it won't run if you've done something wrong with dependency injection. Doing a .NET run really proves it out.